Okay, good morning, everyone, and welcome to the second day of our international conference, Information and Software Technologies ICIST 2022. And let me introduce the keynote speaker, Professor of the University of Agder, Filippo Sanfilippo. And the topic will be snake robots, state of the art. And unfortunately, our keynote speaker stuck in the Istanbul's airport today, and early morning we received the record of his speech and presentation. So unfortunately he can't participate on site, and I will start the presentation right now.
Good morning and welcome everyone. I'm very glad to be remotely attending the conference, and I'm grateful to the organizers, especially Kanos University of Technology, and I'm very happy to participate to the International Conference on Information and Software Technologies. So I'll go ahead and share my screen. The title of my talk is Snake Robots, State of the Art. My name is Filippo Sanfilippo. I'm a professor at the Department of Engineering Science, Faculty of Engineering and Science at the University of Agder in Norway, in the campus of Grimstad. So my major is mechatronics. And in my next slide here, you can see the research center that I belong to. It's the top research center in mechatronics. And my specific research team is collaborative robots. As you can see here in this figure, I have represented the types of robots that my research team works with. So specifically, we have three layers, as you can see: the green layer, the red layer, and the yellow layer. The center core of our logical framework here is represented by robots that can be considered as carriers. So basically, we have robots that are operating in different environments, from robot that operates in water, so aquatic robots. Then we have robots that are bio-inspired, like robots with legs. In this case, this is a five-legged robot. And then we have snake-like robots, which is the core topic of this presentation today. And we also have aerial robots or drones. So as mentioned, these are carriers for us. These robots can carry sensors and deploy sensors in the environment. They can interact and apply changes to the surrounding environment. Then the carrier's robot can also be complemented with manipulators, so they can transport a manipulator. And this is why we are also, our team is also working with robotic manipulators of these different sizes, from small manipulators like grippers and robotic hands to bigger manipulators like industrial robots, as you can see here in this figure. Then another important layer for us working on collaborative robots is the interaction with humans. So in my field, the idea is to have robots working together, so robots with robots, but also robots working with people. That's why the human interface is very relevant for us. So in this layer here, you can see a few examples of human-robot interfaces, starting from this figure here, where you can see the person controlling a robotic gripper, by using an electroencephalogram headset. So basically we are monitoring brain waves, and we are using this as an input signal for the robot. In the center photo here, you can see the use of haptics. Haptics refer to the idea of conveying a tactile feedback to the human operator. So in this case, the human is interacting, is controlling a model of a drone flying around a simulated scenario, and the person is able to perceive obstacles in front of the drone. So basically, we are augmenting the capabilities of the human operator with haptics in this case. Another example here where we use tracking of gestures and finger motion to control an industrial manipulators. My team is composed by different bachelor and master students, and we currently have 4 PhD candidates in the team, and one more is currently being hired. So I'm very thankful to the work of my team members, and without them, this all research couldn't happen. So at the moment, I'm currently the chair of IEEE Norway section, and the chair of the Robotics and Automation Control System and Intelligent Transportation System joint chapter. And I'm also the treasurer of the Norwegian Artificial Intelligence Society. So this concludes my very brief presentation of myself and the team. Let's dig into the topic. Here we have just a short summary of publications and current research projects. Some of them are directly relevant for the topic that I'm going to present. For example, we have one project where we work with augmenting people with wearables, augmenting people capabilities with wearables and haptics, as you can see here. This is a European project, and some other project. In the interest of time, I will go straight to the topic of the presentation. If you are interested in collaboration, please don't hesitate to contact me at a later stage. So today we will explore different capabilities of snake-like robots. So robots that look and behave as biological snakes. And particularly, we are going to explore control, navigation, and guidance of autonomous robots, specifically snake robots. So control means low-level control. It's the first layer which is directly interfaced with actuators and sensors. So that means controlling the movements of the actuators, sensing the environment through sensors. It's the machine, it's the closest level to machine level. Then we are going to look at guidance. Guidance is the series of control algorithm that is used to steer the robot left and right, for example. So basically, it's the logical level which is directly above the hardware level. So assuming that we are capable of controlling actuators and sensors, we can then proceed with guidance by steering the robot left and right. And then one level above this from a logical perspective is navigation. So navigation for the robot means the capability to navigate a certain environment and, for example, go from one point A to an end goal or a final point or destination point. Imagine as we are navigating a map, for example, of the underground or the tube map. So control, navigation, and guidance, these are the three essential levels that we need to design and implement in order to program any robots. And in particular, we are focusing on snake robotics. So why are we interested in designing and prototyping robots that look like biological snakes? This is interesting for us as a team because biological snakes, if we look at nature, they are extremely capable of navigating different scenarios. We can have snakes that move and navigate through sand or rocky terrains. We can have snakes that are able to climb trees. Some species are able to swim underwater. And finally, there are even species that can glide over the air. So as you can see from this picture, these astonishing capabilities of a snake in nature would enable us, if we can mimic it, to conquer all kinds of scenario and to access areas that cannot be accessed with traditional mobile robots. Think about robots with wheels, for example, or robots with tracks. Robots with tracks are a little bit more dexterous, and they can navigate a little bit wider range of scenarios, but still there are cases where robots with wheel or tracks cannot be operated. Think about a narrow corridor or a pipe or a terrain cluttered with obstacles. Think about the Mars rover, for example. The Mars rover, in order to be operational, need to be deployed in areas that are more or less flat with only few obstacles around. And the aim of the Mars rover is to avoid obstacles, while the snake instead can actually operate in terrains that are much more cluttered, and it can actually take advantage of having obstacles by pushing with its own body against them to propel forward more efficiently. That's why we are interested in designing and prototyping robots that are resembling the capabilities of a snake, biological snakes. So, as mentioned, we are going to focus on the design of guidance, control, and navigation algorithms for a specific type of robots, snake-like robots. In this figure, you can see the general representation of how these logical levels are connected with each other. This is a block diagram where we have guidance, navigation, and control. As you can see, the control block is the one directly interfaced with the machine, and we can implement different algorithms. As you can see, there is a package of algorithms that we can have for control. Similarly, for guidance, remember, guidance is the possibility to steer the robot left and right. We can have different algorithms and approaches. And finally, the top layer from a logical perspective is the navigation block, where we aim at giving the robot the possibility to reaching a specific target in the scenario. So going from A to B autonomously, for example, planning for the shortest path or the path that consumes less energy, and so on. We can have different strategies and therefore different algorithms. But from a definition perspective, as you can see, it's very important for the robot to understand and be aware of the surrounding environment, especially when we are going to explore and navigate terrains that are cluttered with obstacles. So sensory perceptual data and external system commands play an important role. That's why if we look at the literature, actually our own team has introduced the definition of perception-driven obstacle-aided locomotion, or POL, to highlight even more that, on the contrary to other robots, that normally mobile robots try to avoid obstacles, snake robots instead actually are obstacle aided. That means that we are going to push and exploit the roughness of the terrain to efficiently propel forward. So the definition that we have given is locomotion where the snake robot utilizes a sensory perceptual system to perceive the surrounding operational environment for means of propulsion. So this again highlights the idea of exploiting the terrain to efficiently propel forward. So perception-driven obstacle-aided locomotion is obviously challenging. And one of the biggest challenge is that the snake itself, from a kinematic perspective, is hyper-redundant. So that means that we have many joints, especially if we look at nature, we can consider the snake as a continuous kinematic chain. So the high number of degrees of freedom which is required to be controlled is a challenge. In the past literature, existing literature considers the motion across normally smooth or flat surface without any obstacles. So in that case, we can say that the challenge from a research perspective is already solved. We can achieve snake robot locomotion in flat terrains without any obstacles. The real challenge is when we have obstacles, and even more challenging is the transition between different terrains. So for example, going from sandy terrains to climbing a tree or steps, or to navigate a narrow corridor or a pipe. So the transition between these environments and the capability of the snake robot to adapt to these changes, it is still a big challenge. And to develop these challenging algorithms and to solve these problems, one of the idea is that we need to test several approaches. We need to have the possibility to test these. But of course, testing this in a real scenario is not feasible, because as we are going to collide with obstacles, this could either damage the robot itself or the surrounding environment. So we need to have an easier and more safe way to test multiple algorithms in order to succeed in solving these challenges. So that's why one possibility is to actually build a test environment, a simulation environment, where we can safely prototype and design new propulsion algorithms to achieve perception-driven obstacle-aided locomotion. So that's exactly what our team has done in the past, in the recent time. We have developed a snake robot simulator that is named Snake Sim. And this simulator is based on the well-known Robotic Operating System, or ROS, which is today the de facto standard in robotics and robotics prototyping. So as you can see, we have designed a digital twin, which means that we have a simulation environment where we can visualize our scenario, and we can also simulate physics, collisions, and all the physics parameters that we need. And then this simulation environment is directly connected in real time with the snake robot, the physical robot. So there is an interaction, an exchange between the visual prototype and the physical prototype. And this exchange is both ways. So then on the top here, you can see the core framework that we have designed. It's a simulator where we can simulate different kind of sensors, different kind of actuators, and we can add different plugins according to the algorithms that we want to design. On top of this, we have the perception-driven obstacle-aided locomotion modeling and control block. This is the place where different algorithms are implemented and can use the bottom layers to communicate with the virtual robot as well as with the real robot. So the main advantage of using ROS, and the reason why we have decided to use it, is because of the big open community that is behind this software. It's the de facto standard. There are tons of libraries and other algorithms that are already available. And from our side, we can contribute to the community, and we are happy to share our research. So when we designed the simulator, we adopted the following design guidelines. We want the simulator to be flexible so that we can collect different sensor information. And if tomorrow or sometime from now we decide to switch or replace a sensor with a new one, we don't need to rewrite the entire framework, where we just replace a software module. It works as if it was a driver for an operating system, meaning that if I have a new printer, I don't need to reinstall the operating system on my computer. I just replace the driver for the printer. This is the way how ROS works. It's a network of connected nodes where each node is representing a specific sensor or actuator or a specific algorithm. So this flexibility was one of the main design guidelines. The other objective for us was to have a robust and reliable software, easy to maintain, modify, and expand by adding new components and features. And finally, the last requirement is that we want our software, our simulator, to be highly integrable with real robots. So as I mentioned, we have a digital twin, so simulated virtual robot connected one-to-one in real time with the physical robot. The simulator is based on Gazebo 3D simulator, which is supporting different physics engines, including ODE, for example, the standard and most used physics engine. As you can see, Gazebo is represented here on this on the left side of this figure, and then our control framework is implemented with ROS and communicating on with the virtual robot as well as with the physical robot. The same exact code is used for controlling the synthetic and the real robot. On the right side, we have what is known as ROS Visualizator, or RVs. This plugin here is used to visualize real-time data from sensors and actuators. In this figure here, you can see a more detailed representation or block diagram of our design simulator. And here you can see actually the detail of the three main blocks guidance, navigation, and control, which we previously mentioned. So the control block is the one that is directly interfaced with both the physical and the virtual robot. Then we have one level above, which is guidance, deciding how to steer the robot left or right. And then the navigation block on top, which means we can use it to navigate and to reach a certain target in a specific scenario, and to choose, for example, the shortest path or the path that minimize energy consumption, and so on. As you can see, the robot can be controlled by an external system command like a joystick, or later on, for example, this manual control could be replaced by autonomous, fully autonomous navigation. So here we have a screenshot from the simulator just to highlight that we can determine all the collision points with the terrain. So as you can see, the snake is represented by modular links that are all the same. So in this case, we are focusing on the logic of the simulator. So the representation of the snake is discrete. We have a number of links that are all identical, and they are colliding with the surrounding environment. So the blue points are the collision points with the terrain and with the obstacles. So these cylinder objects are obstacles, symbolically representing obstacles. In this other screenshot here, you can see the rotation axis and the collision forces. So actually the frame, the reference frame for each link. And from a control point of view, we have developed the first algorithm for perception-driven obstacle-aided locomotion. So basically, in this algorithm, we assume that the snake robot is represented by this dashed line as a continuous curvy line. And the snake is in contact at least with 3 obstacles. As you can see, these black points, circles, represent the obstacles, and they collide on a left, right, left manner with the snake. So basically, the snake is initially constrained. So we are at an equilibrium point. Imagine that the snake is tethered to the ground and constrained by these obstacles. And we have adopted specific hypotheses for this model. As you can see, they are listed here. So the path is represented as S of S, and the obstacle locations, O1, O2, O3, are also known. The snake is always on the path. The snake is planar and discrete. There is no ground or obstacle friction in this first model. The snake is at rest. We are at equilibrium. The snake tail is tethered to the ground. The tether is unactuated. No tangential movements are allowed. A tensile force Fs acts along the tangent at O1. As you can see, Fs is applied here, and it acts along the tangent direction. The snake is perfectly rigid, except at the point where an internal torque can be applied. The obstacles are perfectly rigid and fixed to the ground surface. So we choose to apply an internal torque, which is called tau, at a known point that we call P23, as you can see in the figure. Anywhere on the path between O2 and O3. So these are our hypotheses. As you can see at this stage, these are quite strict hypotheses. So this hypothesis allow us to formulate and simplify the problem from a dimensional perspective. So referring to the reference that is listed in this at the end of these slides, in the interest of time, I will not have the possibility to go equation by equation, but feel free to read our article that is linked in these slides. And most important, feel free to contact me if you have any questions. So I will go straight to the point. As you can see here, after a series of mathematical steps, we can achieve a very important remark. So the tau S, the internal torque, bending torque that we need to apply on the point P23 so that the snake can propel forward, is only dependent on these forces. Fs, that is the tethering force, and F1, 2, 3, which are the reaction forces coming from the obstacles. So, as a remark, for an obstacle triplet model, that's the name we use to refer to the considered model with 3 obstacles. Well, only one control variable, tau S, is needed to achieve obstacle-aided locomotion. The torque tau S can be applied at any point, and it can be seen as a thruster for the snake robot. So as you can see, this simplifies consistently the problem from a multidimensional problem to a problem that depends only on one thruster point. And to demonstrate the algorithm, here I have a simulation that I would like to share with you. As you can see, this is directly filmed from our simulator. On the left side, we have the simulation of the terrain with different obstacles represented by cylinders. And then we have our discrete representation of the snake robot. We are in the presence of 3 obstacles with left, right, left fashion. So we have a triplet obstacle model. On the right side, you can see the data coming from the ROS visualizator, RVs. So on top we have forces, and so reacting forces and resulting force. And here, actually, the snake is also provided with a depth camera on the head. Though in this algorithm specifically, we are not using the camera because we are only doing local locomotion. There is no need for planning for the next obstacle, but the cameras are used for navigation and guidance. So I will play the video one time, and you can see that the snake is propelling forward little by little by pushing against the obstacle, generating the thrust torque that is needed. So now I will show you actually the real experiment with our physical robot. As you can see, we have a scenario where we have like a Lego kind of application. You see, you have a plate, a wooden plate with different holes where we can plug and play cylinders, which represent our obstacles. And then we have the robot, which is also provided with markers, passive markers, so we can track the position. We have markers also on the cylinders, but the cylinders are fixed. So here we have applied exactly the same algorithm, and the snake is propelling forward little by little, as you can see. I'll show you one more time. So little by little, frame by frame, you can see the snake is advancing forward. So now, so far, we have seen a nice research tool, we could say. So a research tool that works for in a controlled environment, in a laboratory, or in a simulation environment with very strict hypotheses. So one of the reasons why it is so challenging to actually achieve snake robot locomotion in a real environment is the fact that in a real environment we don't have so much knowledge of the surroundings. So we don't have enough sensors, especially if we consider to use snake robots in rough terrains or remote areas, or, for example, emergency situations. Imagine fire stoppers using a snake robot to go inside a collapsed building and save possibly people that are trapped under the building. There are no sensors. It's possibly smoky with low light, and therefore we will not be able to use a snake robot provided with several sensors, and we cannot have sensors embedded in the scenario. That's why our research team has tried to move the complexity from the sensory perception side to the mechanical design. And here you can see our first prototype of a snake robot that uses elastic actuators. So that means that we are still using a rigid motor, as you can see here, but the shaft of the motor is connected through torsional springs to the rotation axis of the joint. So that means that we have a hybrid actuation system that transforms the rigid motor into an elastic actuator. So that means that when we have a collision between the link of the snake and the stone or a surrounding obstacle, this collision will not be hard, will not be rigid, but some of the energy is going to be absorbed, and the robot will comply within certain ranges to the terrain. This makes it possible to simplify the sensory perception, because we don't need to precisely calculate the collision points as we have seen in the previous algorithm, but we can just rely on the softness of the robot in complying with the terrain. And here you can see our design. Basically, it's a very simple design. This is a 3D printed module. Again, a modular design with identical links. And we have springs embedded in the actuation system. All the links are the same except for the head module, which is provided with a depth camera, and for the tail. Also, the way how we connect modules together, it's designed to be done without any screws. So it's plug and play mechanism. So here you can see a simulation of the newly designed robot with elastic actuators. Again, we have a scenario with different obstacles. We have the snake operating in this scenario with the sensory perception from the camera. And here we can focus on one specific module. I would like to show you the principle of these elastic actuators. So as you can see here, this is a simulation where we use the exactly same approach. In this case, we have an arm, a robotic arm, but the arm is built by using the same module with elastic actuators as for the snake. And now we are going to make it collide with the box or with an obstacle. So now we will introduce a cube in the simulation environment, and the robot is going to collide with it. So we will notice that this collision is not to be rigid, but there is a small bend that is visible. So basically the the robot is complying and absorbing some of the collision energy. So this is at the core of the newly designed snake robot. So this makes the robot more compliant, but also intrinsically safe for human-robot interaction. So if the snake collides with humans, we are not going to harm them or damage, but some of the energy will be passively absorbed. And this will work even if the software fails, because it's a mechanical feature. So far, we have seen one example of control algorithms for snake robots. The next chapter is going to look at one possible example of guidance. Remember at the beginning, I told you we are going to look at control, navigation, and guidance. So guidance means steering the robot left and right. Our team, to achieve this, has again taken inspiration from nature, and especially considering what is known in literature as Breitenberg vehicles. Breitenberg vehicles are simple representation of a system where the actuators, in this case, we have a robot with wheels, as you can see, left and right wheel, and the robot is provided with the left and right sensor. So Breitenberg vehicles connect directly the motion of the actuators to the sensors. So basically, imagine that this robot can either converge to a certain stimulus, as you can see if there is, for example, a light source, either converge towards the light or diverge from it, according to how the mathematical model is implemented and how the wheels and the sensors are connected with each other. So we can represent the stimulus as S of x. The wheel speed control function is given here. So it's a function of the stimulus. And the wheel speed depends on the corresponding sensor. So decreasing sensor speed connections, so the derivative is smaller than 0. So this kind of approach has been successfully used for sound-based steering, light-based steering, chemical-based steering. So imagine to replace the light with sound or with a gas, CO2 emissions, for example. But in literature, this category of algorithms, Breitenberg algorithms, had so far been applied only to robots with wheels, so wheeled robots. Our team, for the first time in literature, has ported and implemented these algorithms for snake-like robots. And now I will show you the idea. As you can see, our robot is modeled here with passive wheels. And the idea is that the robot is either attracted or it's repelled by a light source, represented here with the yellow gradient. So basically, we have two sensors on the head of the robot, and the robot is either following the light or going away from the light. The robot is moving with sinusoidal reference, ondulatory locomotion. So as you can see here in this video, we have a simulation where we use 10 different random configurations for the snake. So they start with different orientation from the same position. And we have a gradient stimulus that is constant. So there is a light source on the right side with yellow, and there is a constant gradient decreasing as long as we go to the left. So when the robots start moving, they gradually converge towards the right direction of the gradient and towards the light. So little by little, all of them are correctly oriented and they reach the most bright side of this figure. Similarly, we can simulate the same approach with the linear parabolic stimulus. So there is a light source here, but this time we have linear parabolic stimulus. So as you can see, again, 10 configurations that have started with random orientation, they gradually converge towards the light and the brightest point. Here we have, again, one similar simulation where this time we have parabolic stimulus. 10 different robot configurations started at random. They gradually converge towards the center, which is the brightest point of the figure in this case. So as you can see, this is working for snake-like robots, ported from robots with wheels to snake-like locomotion. And this is for us a very relevant achievement, because then we can use this, for example, to explore remote areas where we need to save a person, for example. So we can send a snake robot inside a collapsed building. And so, for example, imagine that you are tracking a person that is making some sound, so being still alive under the collapsed building. So we can detect the sound and we can make the robot converge and reach the person. Imagine similarly to a rescue dog. The rescue dog will hear the frequency of people possibly asking for help, and the dog will also smell the presence of survivors. Similarly, we can give the smell and the hearing to our snake robot. So we have also applied the same principle to another interesting robot, which is a robot with leg. And it's a robot actually designed and prototyped by Boston Dynamics. So in the interest of time, I will show you just a simulation of, so here we're talking about quadrupeds, robots with legs. They are moving from one side, from the darkest side to the brightest side, as they are attracted by the light. So again, here, it's another contribution where we have ported Breitenberg algorithms from robots with wheels to robots with snake-like robots, and here to robots with legs. So I will directly jump to the part where we have implemented this to the real robot. As you can see, the robot looks like this. So it has 4 legs. We have built a rig on top of his back, where we have mounted an array with microphones. So this array of microphones is used to detect the sound. So the person here is clapping in this case. The robot is detecting the sound and changing its orientation accordingly. So now basically the robot is going to follow the direction of the sound. As you can see, it's rotating. It's steered by the sound. So let me show it even better. Let's start from here, the video. So the student is clapping. The robot is changing its own orientation and facing the direction of the sound. And here, I would like to show you another application which might be useful in case of using the robot for search and rescue robots, where we are combining locomotion with grasping of objects. So basically, the idea here is to use part of the body of the robot to grab an object. So the robot is able to follow a specific path, so to achieve quite advanced navigation, reach the target and grab it and bring it back. So this is done in a simulation environment again, and I would like to show you the video of this. So in this simulation, you can see the snake robot propelling forward and following the blue line, so detecting the line and following the line. On this plot here, you can see in real time the torque that each motor is executing while locomoting. So as you can see, the robot will follow the line, being able to steer itself and to perform a turn. And in the interest of time, I will speed it up to the point where we get closer to the target, this green cube. So once the target is reached, the robot is going to use tactile feedback. So it's going to touch and approach the robot approach the object little by little. As you can see, it's feeling the presence of the object by touching it gradually. And you can see also the torque that is changing accordingly. So once we reach the point that we are in a good position for grasping, the robot will actually wrap around the cube and switch to a different locomotion pattern, secure the object and switch to a different locomotion pattern. And we'll start bringing back the object to the base point. So as you can see now, it's shifting and sliding back to the blue line, detecting the blue line, and start to move back. And according to the green color, the color of the object will be delivered to the green area in this case. So I will speed it up in the interest of time. As you can see, little by little. Now the robot here is looking for finding the green spot. As soon as the green spot is detected, the robot will converge towards that point and release the object. Once we are here, the object will be released. We open up, we push the robot inside the designated spot, and we proceed with finding the red cylinder now. So we reach the cylinder. I'll show you just the most relevant point. We grab it, we secure the object, and we switch the locomotion gate. And again, we find the blue line, we navigate back to the start point and detect the red circle, which is the point of releasing of the object. So as you can see here, we have demonstrated a complete control stack from control, guidance, which means steering, and navigation, which is exactly the scope of today's talk. So finally, one last topic that I would like to discuss with you is today we have the possibility to apply machine learning to our control algorithms. And machine learning actually opens up to a variety of possibilities. In fact, by using machine learning, we can deploy more robust and flexible algorithms. For example, in this article here, as you can see the reference, researchers have used genetic algorithms to program the robot to achieve the fastest possible side-winding locomotion in a wheel-less snake-like robot. So as you can see, here we have generations after generation, we evolve the most fit configuration, to the most fit locomotion gait to achieve the fastest movement. So one of the main advantage here, you can see that this is actually working. This is a sequence of simulation steps where we see that the snake robot is propelling forward. One of the main advantage of using machine learning is that this kind of algorithms can adapt to changing situations. So for example, if we imagine that one of the link of our snake robot is damaged, the remaining links will still work, and the control algorithm will still be able to adapt and to make the robot move forward. So as you can see, even with damaged segment, the robot is still able to move. So robustness is one of the main advantage of using machine learning for this kind of applications. And as a final video, I would like to show you now the frontier research where we are working. Because basically now we have seen how the snake robot can be controlled and how we can achieve control, guidance, and navigation. But from an interaction perspective, how do we want to control the robot? So basically, we have seen that we can send a signal. We can use a joystick, for example, to remotely control our snake robot. So we can send a signal from the operator to the robot. But from a human-robot interaction, it will be also interesting to receive some feedback from the robot. And this can be done in terms of visual feedback. So we can use a camera and we can show what the snake is looking at. But more intuitively, we could use haptics, so tactile feedback. In the previous video, you have seen the snake touching, gradually grasping objects. So if we could convey that feeling to the operator, we could increase awareness, especially if we consider operating the robot in an emergency scenario. So in this video, we can show you a prototype of a haptic device, low-cost haptic device that uses a set of gloves to interact with a virtual object. In this case, it's a piano. So basically, by wearing this set of gloves, the user can perceive patterns, force patterns, or feedback, tactile feedback, so that the user has the illusion to physically touch the keys of the piano. So for a snake robot, imagine that we could use this set of gloves to steer the robot and to perceive what the robot is actually touching. So as you can see, by using also VR headsets, we can have a very immersive experience which involves visual feedback and tactile feedback and also audio feedback. So to summarize, in this talk, I have described the state of the art for snake robotics. We have seen examples of control, navigation, and guidance. And finally, we have closed the loop with haptics and tactile feedback. So in the interest of time, I will close here my presentation, and I will be happy to receive any questions or comments or any possibility, explore any possibilities for collaboration, here you can find my email contact, and my research articles and updated list is can be found either on my website or on Google Scholar. So feel free to contact me. I'm sure we can find possible collaborations in different applications. So thank you again for your participation, and again to the organizers for inviting me to the conference. Thank you very much.
Thank you. Okay, thank you for interesting presentation. And the professor provided his contacts, so as he mentioned, you can feel free and ask questions or provide kind of suggestions or proposals for cooperation or something. So thank you very much, and now keynote section is closed, and now we'll have 30 minutes coffee break, and at 11:30 we will meet in another meeting room next to registration, and we'll have the second part of a special session on intelligence methods for data analysis and computer-aided software engineering. So thank you very much, and see you after half an hour. today in this section, and regarding the time limit, just 15 minutes time slot for each presentations, 10 minutes for presentation, and 5 minutes for discussion. Okay, so I would like to invite Professor Rima Gustienė, and the title of the presentation will be Holistic Approach for Representation of Interaction Scenarios in Semantically Integrated Conceptual Mode.
Okay. Yeah, thank you very much. Hello to everybody. My name is Prima Gustienė. I am associate professor from Karlstad University, Sweden. And I'll present today the paper we have written together with Professor Remigijus Gustas about the conceptual method that we are using. It is a continuation of our research that I was presented before. I present holistic approach for representation of different scenarios in semantically integrated conceptual modeling. So it was something. So agenda of my presentation will be as following. I'll present first of all goals of this paper. Then I shortly present problems or why we need a new holistic approach, why it is not enough to have these traditional methods that we are using in conceptual modeling, why modeling and integration, these two concepts, are very important when we want to visualize our requirements. SICM, or Semantically Integrated Conceptual Modeling, was made by us and research group at the Karlstad University. It was a part of my dissertation. And actually, at the end, I present the modeling examples and finish my presentation with the conclusions. So what are the goals? Several goals with this paper is that we present our SICM, that we call now the method, which enables stability and flexibility of diagrams that are very important for managing the changes that we introduce. It could be organizational or technical changes in the requirements. The paper also shows, especially this paper, how we can introduce the alternative actions of different scenarios or business processes. And as well, I'll show the example how we can show underlying interaction loops and overlying interaction loops. I'll talk about. So it was several goals of this paper. So why we need the holistic approach? Why this new method was constructed? First of all, because there is a lack, still we have a lack of semantic integration principles for graphical representations of different aspects of enterprise systems or of some problem domain of some systems. And when we say different aspects, first of all, we have two different important aspects, is data and processes. Value flows that that are sending to, for instance, between or among different actors with the traditional methods cannot be explicitly captured. It is unclear how we can integrate, for instance, data and processes, behavioral aspects, that is the changes of the objects of data, and of course managing complexity. The systems now are very sophisticated and we cannot reduce this sophistication, but we have to manage to learn how to manage complexity. And present some decomposition principles. Now they are very vague decompositions that we can decompose into smaller problems, so to say, and then to show how they will build as a holistic model. And of course, evolution of the models is difficult in traditional conceptual modeling methods if we have to introduce new changes or new loops. Modeling and integration, these two concepts are very important, we think so. And why? Because the greatest value of a picture is when it is forces us to notice what we never expected to see. And that is when we visualize the requirements and how we can perceive them. Modeling helps us, or system developers, first of all, to visualize, to specify, to construct and document structural, it's data, dynamic aspects, that is behavior, interaction. Models, first of all, are used for people to communicate various architectural solutions. Modeling is only the only way, we think so, to validate and verify requirements. And of course, integration. It's not just analysis of the requirements that we do, but we have to integrate all the parts, and this is the synthesis that is very important. So semantically integrated conceptual modeling method that we call now, and you, of course, I cannot present here the whole method, it is a big one, but the essence of this method, it's a new way of thinking, is based on interaction principles among different actors. And these different actors could be seen, can be expressed in different way, I'll show later. And this way of modeling that we are presenting in this method enables possibility to data changes using just one construct. For instance, if you know YAML, there are a lot of diagrams representing different aspects, but we use just one construct. And that is where the framework, I am not talking about the framework in general, but it's of 3 layers. We have pragmatic, we start here at the pragmatic level where we discuss the goals. Then we show how we decompose these goals in the form of data and processes at the semantic level. Here, the conceptual modeling takes place. And then, of course, these 2 levels are implementation independent. And then we go to the 3rd level, that is syntactic level, how these actors or systems will be implemented. So actually, at the conceptual level, we use this construct. You see the notation. When this method was built, we were thinking about the philosophy. You know, every method or methodology has to have philosophy at the back, in the background. And this philosophy should be very understandable for people. So actually, when I was building this and I was thinking which philosophy we can take into consideration, I thought that communication or interaction, we all know what is communication. When we communicate something, when we communicate, for instance, or interact with another actor, what happens? Some action takes place. So actually, there are 2 important perspectives when we talk about communication act or communication action. Intersubjective perspective between the actors or subjects, and objective perspective. What happens at the same time with data? Because actually data is input and output from the process. So it's very important, using this construct, we can integrate both these aspects. So characteristics of SIG method The philosophy is based on Bunge's philosophy. He's saying that the world is constructed of the things, and we see also every enterprise or problem domain as a system. So actually these things everywhere, and we are the part of the systems, are interacting. They are interacting components. And when subsystems interact, they cause changes to the objects. And we see these changes with the properties, as you know, the attributes it could be. And these dynamic aspects of subsystems, that can be one of the actors, is expressed using interaction dependencies, which is gradually refined in terms of structural and dynamic. It means that structural is data, and dynamic, how data changes. So actually, this way of thinking based on interaction and integration of these internal and external behavior provides us, or modeling flexibility. We can introduce new changes into the same construct. And the most important, that we use just one construct or one modeling notation. So actually how we see in this conceptual modeling, in our Sigma method, how we perceive and understand the concept. Here you see the notation. So the concept can be an actor, instance as an actor. Actor could be a subsystem. It could be a person. For instance, we can use, here you see in legend, this is inheritance link. So requester could be a kind of an actor, performer could be a kind of an actor. Another subsystem is classification, or the instantiation. So actually, when they interact, what happens? We have some flow sending from one actor to another, and flows, it could be information flow, the notation you see here, or resource flow or material flow. And then when we have in the objective part, we can see classes. Concept can be a class, that the instance of the class is an object, yes, and they have properties. It could be the attribute, and object is an instance also that have also properties. I'll show the modeling example. It will be more easier to understand, but of course it's the main notation for our construct building. And here you see the same semantic dependencies, and maybe you are familiar, of course, with them if you know other approaches. So it's classification, inheritance, composition, attribute, how attribute changes, interaction, and transition. And here you see multiplicity and how we see the concepts or of this construct. Two important things that are specific for this method is that we use just composition, not aggregation, and that our multiplicity always have no zero cardinality. So actually, representation of different actors, how they can be represented in our, there you see the construct, and then it could be a role, or it could be a human being, it could be a software, hardware, business component. So actually, they can, it could be among different or between different actors. Here is the example, a very simple loop. So actually, the construct is based on loops, on interactions. So this is a very simple interaction. The hotel, the room guest requested for the room, and the hotel sends or presents, this is material flow, provides hotel room. It means that room is created and have one guest, that is a customer, and at the same time, the guests have to pay. It is material flow, and the action pay to the hotel is activated. So actually, this is the main interaction loop. And this loop, if we have the loop, it should be closed. You cannot, it's very important, because if I ask you, you have to answer for me. The loop is not closed. We can get discontinuity. That is one of the undesirable features of information system development. So actually, I'll show 3 types of constructs of actions that we are using in this SIGM construct. And I begin with the construct of creation, or the action of creation. So actually, we see the agent that's sending the flow. Creation action take place. It means notation is as following. The arrow goes from action to class. It is creation. We have termination. If we want to delete, the flow is going to termination action takes place. It means that the arrow goes from class to action. This is deletion. Now what we have, the third type, is reclassification. We put together into creation and termination, and we have the reclassification action that is very important to show the differences in attribute properties. So actually, when we delete and create, that is reclassification. So actually, if we want to reclassify the object of the class, first of all, we have to in precondition class, we have to delete, and to create in the postcondition class. So actually, here you see the reclassification action, again, the notation. So I am not just, you can read. Here's the example of this reclassification. As I said, when the customer sends the requirement of room, request room action takes place. It means the room reservation request, the object, is created that have one type of room, desirable according to our requirements, and is sent to hotel reservation system. If the room is available and the hotel reservation system provides reservation, what does it mean? It means that create reservation action is processed. It means that, what does it mean? Hotel reservation request will be deleted. Arrow shows that it goes from the class to the action, and a new object of hotel reservation is created. And here you see, what is hotel reservation? It has to have one identified customer. The system has always to check if you are a customer or not. And of course, reserved room. And customer identified is also a customer that was requested, that requested hotel reservation. So actually, notation that we can also show in which state the object is. So as I said, these loops should be always closed. So actually, if I send the request, the promise should be sent to me. What is very important with this semantic link inheritance, that if we show the actor, and this is a parent class and this is subclass, guest is a kind of a customer, so actually we can follow the commitments, responsibilities, and obligations from different actors, what they have to do and how they have to act. What can have to do he or he? So actually these inheritance links or other links, semantic links, helps us to see, to follow. And this is a little bit more difficult example of alternative actions. So actually, for instance, if requester sends the request to the performer and he promises to do, and the request is created, so we can show also alternative actions. What happens if he rejects? So actually, when he promises, and promise is created, and we have perform, and the result is creating, and I have to pay for this delivery, but what happens if the performer rejects? So rejection is created, but we see request will be deleted, reject will be created. And then, for instance, what happens if I, as a requester, would like to withdraw my request later? I am not satisfied. Or the performance can withdraw his promise, in spite of the fact that in previous loop, the promise was created with the input of request. So actually, we can follow these loops, and we see that these loops should be closed, and what happens with the intersubjective or interaction loops, and what happens to data at the objective part. So we can, of course, we have to know the notation and to follow it. And the last slide, or almost the last, what is very important, that we can show loops at the very high level of abstractions. For instance, how we create reservation. I send the room requirements and reservation was created. It's on the very high level or overlying loop. But what happens, it's not enough. What happens inside? In order to have a reservation, hotel reservation, we have to process customer and we have to process room. So actually, hotel reservation sends me offer of the room or the list of the rooms that I have to select. So actually, this loop is underlying. At the same time, we can see that when I select the room, reserved room is created, and then when I select the room, what happens then? Hotel has to check if you are a customer or not a customer. So actually now request to authorization take place. Offer will be deleted and a new customer not identified will be created, and then customer has to enter customer data, and he will be if he is a customer, so he has to provide his customer ID. If he is not, he will be created. So actually we can show how these underlying and overlying loops can be provided. So actually conclusions. Interaction loops in modeling are very important for system architects to separate concerns. And when I say concerns, it could be a part of business process. It could be one use case. It could be a part of scenarios which have understandable structure. The method helps to integrate data and processes. And behavior, of course. And this method provides stability and flexibility when of the diagrams if we want to introduce new changes and manage complexity. And of course we have different possibilities to introduce into different patterns or alternative behavior, parallel, sequential, and interactive. And the most important that we use just one construct or one diagram. So thank you very much.
I have one question, and what is, for example, what is advantage of your proposal comparing with, for example, business process modeling language, PPMN?
Yeah. You know, it is a holistic approach. What does it mean? It means that here I talk just at the semantic level, but this method, we start at the pragmatic level and go from goals analysis and show how we go further to semantic level and even to implementation. So actually it is a difference because it is holistic and provides principles and notations and of course language, how we can follow traceability and to verify and validate our requirements.
Thank you very much.
Thank you.
Thank you for interesting presentation.
Thank you. Thank you. I'll finish if it is. I have to ask.
So next presentation we will have remote way. Okay.
Thank you very much.
So, okay, can you hear me? Muhammad, can you hear me? Ah, sorry. Good afternoon, can you hear me?
Yeah.
Oh,
No.
great. So the title of next presentation is a model-driven framework for design and analysis of vehicle suspension systems. So time limit 10 minutes for presentation, so the screen is yours.
Okay, thank you. This is Mohammad Wasim Anwar, and I am going to present you the research work titled A Model-Driven Framework for Design and Analysis of Vehicle Suspension Systems. This work was partially supported by Knowledge Foundation through MODE project. This work was carried out in collaboration with MDU and National University of Sciences and Technology, Pakistan. The outline of this presentation is, in first section, I will set the background of this research. The proposed framework will be discussed in the second section. Then proof of concept will be provided in the third section. And finally, conclusion and future work will be discussed. So let's start with the background. The advancements in automotive industry allow vendors to introduce luxury vehicles with premier comfort level. The vehicle component responsible to provide comfort level during ride is known as suspension system. Generally, suspension system can be categorized into three main classes: active suspension, semi-active suspension, and passive suspension. The design and implementation of suspension system is a complex process. Furthermore, analysis of suspension system usually requires complete low-level implementation that eventually leads to production delays. The existing studies for vehicle suspension system like reference 1, 2, etc. mostly deal at lower abstraction level with high implementation complexity. On the other hand, model-driven engineering is a renowned system development approach where system design and analysis can be achieved at higher abstraction level with simplicity. There exist comprehensive MD approaches like ICIST, ADL, AUTOSAR, particularly meant for vehicular embedded systems. In this context, different aspects of ICIST ADL have been frequently researched in state-of-art studies like reference 4, 5, etc. However, its application, particularly on vehicle suspension system, is hard to find in the literature. So to summarize, existing studies for vehicle suspension system mostly deal at lower abstraction level with high implementation complexity. In addition to this, renowned MD standards like ICIST ADL have not been explored yet in the context of suspension system. So there is a dire need of an MD framework that supports the modeling of suspension system at high abstraction level, provides early analysis feature in modeling phase, and complements the existing standards like ICIST ADL in full vehicle development workflow. To achieve these objectives, model-driven framework for vehicle suspension system is proposed here. This proposed framework is developed in 4 steps. In first step, E-core meta model is developed. Then OCL constraints are specified at the meta level to achieve the early analysis capabilities. Based on the first 2 steps, modeling tool is developed in the ICIST platform. Then finally, model transformations are written to generate the target MATLAB Simulink model from the source model. So let's discuss the meta model. So here you can see that different concepts related to the suspension system are included in the meta model, like chassis, air spring, spring, compressor, damper, electromagnet, and etc. So this is the symbolic representation, and this meta model is currently only meant for the active suspension. But of course, further extension can be performed to support the other suspension system characteristics. In next step, meta level OCL constraints are specified. For example, let's discuss the first two constraints, that the maximum displacement that an actuator can counter is less than 0.3 meter. And this OCL syntax is also specified here. In the second constraint, it is specified that number of springs should be less or equal to the number of tires in the system. So similarly, different constraints can be written as per the requirements. So this is the modeling tool that is developed in the ICIST platform. Here you can see the palette where different modeling concepts are available, like chassis, spring, etc. And this is the modeling workspace where user can drag and drop different concepts. So this is the sample template for model transformation to generate the MATLAB code. Different templates have been implemented in this research. This is a sample template, and we have performed this in the Acilio using model to text transformations. So now let's come to the proof of concept. So the application of proposed framework is demonstrated through A6L limousine use case. Here I will discuss the modeling, early analysis, and model transformation and simulation of the use case. So let's start with the modeling. So this is the model developed developed through the proposed framework. Here you can see the chassis, springs, and different attributes are specified in the properties. Here in the early analysis, the meta level constraints are come into the action, and here you can see that the maximum displacement tag value is 0.4, while we already discussed that it should be less or equal to 0.3. So the validation error are displayed to the user right in the modeling phase to achieve the early analysis. So this is the simulation in MATLAB. The code is generated through model to text transformation. So come to the conclusion and future work. So model-driven framework for vehicle suspension system is proposed here. It allows the modeling of suspension system at higher abstraction level. It allows to perform the early analysis and also transform the source model into the MATLAB Simulink target models. So future work includes the inclusion of advanced temporal aspects. Currently, the timing related concepts are missing in the proposed framework, and it is very difficult to model or analyze the complex suspension system without temporal aspects. So we are working on it, and in the future we will include the temporal aspects. Another future work is the enhancement in the transformation rules. Currently, we have just implemented 2 or 3 templates for the transformation to transform into the MATLAB Simulink code. But in future, we will enhance these transformation to be applied on the multiple use cases broadly. And finally, integration with ICIST. So ICIST is a renowned model-driven approach for the development of vehicular embedded system. So idea here is to integrate the results or the modeling context of the proposed framework with ICIST. Here we have performed a few early analysis, and we believe that it could be achieved through the ICIST requirement validation and verification package. So in this way, the generated code can be integrated in the ICIST workflow. Thank you.
Okay, thank you very much for interesting presentation, and I have one question. You noticed that this research was funded by MovDev project. So is it Horizon 2020 project or not related?
Kindly repeat your question. It is the MovDev.
Okay, I found in your report that this research is performed under the MovDev project. So yeah, I wonder, is it Horizon 2020 related research or not?
Yes, I mean, it is partially funded. It is not fully funded. Basically, we are working on the ICIST workflow in the MovDev project, and this is just a part of it.
Okay.
So it is not fully funded.
Okay, I understand. Okay, more questions? Okay, we have more questions from on-site participants.
Okay, hello. Thank you for your presentation, but and I was wondering, are you creating some kind of goal target function that you're going to, I don't know, find a maximum or minimum because you want to, I don't know, find a solution that reduces the vibrations in the system, or what? What is going on? So you are willing to minimize something, displacements, vibration, or are you seeking for some kind of frequencies and then I don't know, update some parameters? I'm not sure what is going on.
Thank you. Thank you for your question. Basically, the idea behind the proposed framework is to provide the higher level of abstraction. For example, let me explain this. In the existing studies, you have to write the low-level code because in the existing studies, the current modeling or abstraction level is missing as far as suspension system is concerned. So here the idea is to model the suspension system at higher abstraction level, as you can see here. And then it will automatically transform to the low-level code. So it will facilitate the user and hide the internal complexities. This is the first objective, and second objective is, if you can see here, we have specified the meta-level constraints. Although these are the very basic constraints, I mean, it is not possible to develop a complete suspension system through these constraints, but this is the proof of concept. You can include the complex constraints, and here this is the tag values. These are basically applied on the tag value. If you can see here, it just displays that the displacement of one actuator, because there can be thousands of actuators in the suspension system. So it is really difficult to analyze what are the values. Even if it is a human error, you will be able on the click of a just button that this actuator is violating the constraints. So it should be fixed before you proceed further. I think I answer your question.
Okay, thank you. Thank you for presenter once more. Okay, that's great. Okay, thank you. And And next presenter, we will have on-site presentation. So the next presenter, I would like to invite the next presenter, Chandana Ravikumar, and the title of presentation is IoTS applications powered by piezoelectric vibration energy harvesting device. Okay, the floor is yours.
Hello everyone, my name is Chandana Ravikumar. I am a third year PhD student of electronics in KTU. And I'm actually quite nervous today because my parents are here from India and I'm so nervous to talk in front of them, but I'll do my best. My topic is piezoelectric energy harvesting for electronic devices from environment. In this paper, I present about the IoT applications powered by piezoelectric energy harvesting device. So as we all know, piezoelectricity is about the generation of voltage by the application of pressure. And pressure, we mean it can be stress, it can be bending, it can be strain, it can be twisting of the piezoelectric material. As we see here, a small diagram that shows that when we apply some kind of tensile stress, when we bend the material, we are able to generate a bit of voltage, which can be used to help supply power to electronic devices and IoT applications, as we see in the block diagram, where we have a natural vibration source. In our case, we are trying to implant our energy harvesters in places where we have no supply of power, or when we also have existing abundant vibration. It could be in a grass mover, it could be inside a stone cutting device, it could be on a railway track, it could be on just inside the asphalt on the road, if we have enough vehicles that can vibrate the road to suit our resonant frequency of the harvester. So the problem is that nowadays we don't have enough power being generated by the harvester because of the loss of mismatch, because of the loss of impedance mismatch that happens between the mechanical object and the electrical object that we are trying to supply energy to. So we are losing up to more than 50% of the harvested power. So my job is to reduce this loss that happens because of impedance mismatch. So with proper theoretical modeling and practical investigation, we can build an energy efficient multi-layer piezoelectric energy harvester. So since I also did my master studies at KTU, and with 2 years of PhD research also, at this stage we are able to construct that harvester, a real harvester after modeling. And this is how it looks, just a model of it. First, I have actually a prototype of that model. So basically we have a steel base, and on top of the steel base and at the bottom we are sticking the PVDF layer, which is a piezoelectric polymer. And we are attaching a steel tip mass that can help it to vibrate at a certain frequency that we want it to vibrate at. When we are fixing this at the base of the mechanical device, it's able to vibrate at a similar frequency as the frequency of the machine that's vibrating. So that is when we have maximum output generation. With modeling results, we know that this gap between the tip mass and the fixed end that's the way to find the optimum voltage value that it can produce. And also the proof mass can also help us to make it adaptable to varying atmospheric vibrations. So by changing the tip gap and the proof mass, we can make this product more universal to other applications also. This is how the electromechanical model looks like, because when we generate the voltage, it's going to be a sinusoidal wave, but we need a rectifier to rectify that output and give it as a DC output, which can be stored in the supercapacitor, which is then the power supply to the sensor. And here, this is a Schottky diode rectifier. Initially, we started off with a normal diode rectifier, but then we had a lot of losses, and we understood that using a Schottky diode helps cut down a bit of loss. This is the experimental investigation setup. It's quite clear that the cantilever has to be simulated in an environment that has vibration. So we used an actuator to excite the cantilever, which is powered by a signal generator and an amplifier. And then output is seen in the oscilloscope, and the input is measured by an accelerometer. The results, to first compare, we only know that the result is okay when we are able to compare it with another product which is already existing in the market. So we have a Mia's company, commercial company piezo sensors that give up to voltage about 3.5 volts RMS voltage. So our harvester gives about 25 volts for the same input acceleration, so which is about 5 times or more power generation for the same input. So the results are presented here. So it is about 5 times, as I said, the power generation is more than 5 times, it's 1,000 times more, because when you multiply it with voltage again and divided by resistance, the internal resistance, we have a much higher power density compared to the other existing works that we see with the other authors. It's pretty high. Ours is 9.26 microwatts per millimeter cube per G, which is almost comparable to the best performing PVDF energy harvesters in the market. This is an application that we are currently working on. So currently the idea is to implant our proposed energy harvester in outdoor power products like chainsaw machines and garden tractors or tools for construction, which have abundant mechanical vibration that can be converted to electricity. So this can help in giving energy to sensors that are maybe temperature sensors or location trackers, or any other IoT application can be powered by such harvesters. Yes, and a brief conclusion is again that it is very up to date with the current works. It's more than at par with the ceramic piezoelectric energy harvesters as well, and this is attributed to the reasons that we are using an optimized design of the steel plate support, allowing higher amplitude of cantilever deflection and the longer length to length ratio, and it's more reliable and has a much longer lifespan, because we also tried to do thermocycling of the product, and we understood that it can run over for more than 5 years. When we understand that if we use a battery, it is up to maybe 2 years it can supply energy. But if we have a harvester like this implanted with the sensors on asphalt or in any other place where it's impossible to have replacement of batteries, this can serve up to 5 years. So that is our first point to say. Thank you.
Thank you for interesting presentation. Questions? Okay, we have questions from on-site participant.
Yes.
Okay, thank you again for the presentation. And what are the possibilities for your device to be upgraded maybe for other ranges of frequencies? Is there any possibilities of expanding the range?
Yes, that is a very good question. You have another question, or that?
Yeah, maybe there would be another one as well, but maybe later. or you want to get it in advance?
Yes, because then I can maybe correlate it.
So when you were producing, engineering this device, you were to know that in the impedances would match, yes? But how you're going to, let's say, evaluate it and, let's say, update the parameters in your harvester when you know the exact impedance? You're going to switch it, something like that? What are you going to change in your device? For example, in prior, you don't know the impedance, that acoustical impedance you're going to use on that device. Yes? So how are you going to modify it prior the application?
Okay. So The questions are so interesting. So the first one, as you said, it is so hard to adjust the resonant frequency, but there is still a possibility, because when we tried it in lab, we tried to change the gap between the fixed length, the fixed end, and the tip mass. So when we vary that length, somehow the resonant frequency of the harvester is changing, because it gets more space to expand. So the inherent property of the material also changes. But the impedance mismatch is a problem always, because it's something that's more within the material and cannot be changed, because the internal resistance has to be equal to the external resistance for us to have maximum output. But we are working on having more layers. Like as I said, we just have 2 layers in this sample, 1 layer at the top, 1 layer at the bottom. So if we add more layers, we are somehow also changing the internal resistance of the...
And technically, is it challenging to put layers, additional layers?
Oh, it takes 24 hours for the glue to dry. So...
It's none. Okay. Keep going.
Thank you. That's it.
Okay, more questions?
It's similar to my colleague's question about this vibration frequency. So when you saw that chainsaw, electrical chainsaw, maybe it has some constant frequency which you can adapt to.
Yes.
And if you change it to another brand of chainsaw, it will have slightly different vibration. So how do you adapt it when you transfer it to another vibration frequency?
So we changed the length of the tip mass.
But
Again,
it's done mechanically. It
is done mechanically.
So it's not yet adjustable automatically. Okay,
No.
I see. Thank you. So there's a room for improvement.
Correct.
Okay, and maybe the last question, I would like to know, did you thought about the commercialization possibilities of your proposed solution?
It is already being used by Hoswana. Hoswana is already using these harvesters in their machines, in their chainsaw machines, in their stone cutting machines. They already have these harvesters installed, which helps in tracking the location of the machine.
Yeah, okay, and it is your proposal, your result?
No, but it is with my team, with my supervisor. And there is also a startup we are doing the R&D for a startup which is called Viso. It's based out of Vilnius.
Okay,
It's
okay, understand. Thank you. Thank you. Oh. Okay, so now we have the last presenter in this section. So we will have a remote presentation. So do we have a presenter? Do we have the presenter?
Participants 1. I guess that's you.
Not yet. Yeah? No. Okay, so in case participant will join us later. Join us later, maybe we will provide the presentation next section. But okay, so today we close this section. So thank you very much. Thank you very much for all the presenters. Thank you very much for participants. And now we'll have 1 hour lunch break. And next section named special session on language technologies, chaired by my colleague, will be chaired by my colleague, Professor Jurgita Dzikienė, on 1:30 p.m. So we have 1 hour lunch break. Thank you. Thank you very much.
Hello everyone, it's nice to see you here, and let me start the session on language technologies. Unfortunately, our first presenter is not here, so we'll switch the presentations, and I invite Vytautas Rudžionis. He's going to give two presentations, one after another. So the first one is efficiency of end-to-end speech recognition for languages with scarce resources. And another one is improvement of speech recognition accuracy using post-processing of recognized text. Please.
Thank you very much. I will open my presentation. I will try to deliver them one after another as one single presentation as I speaking, because both of them are in fact a logical continuation of the same project, of the same activities. And first presentation, I will speak about our attempts to apply end-to-end speech recognition approach to such problem as recognition of Lithuanian spoken language, large vocabulary Lithuanian language spoken. What is end-to-end speech recognition? For decades, I even wanted to say for centuries, but that's of course essentially not completely true, of course, but for decades, the main paradigm of speech recognition as maneuver, a recognition task, was first to calculate some type of features. In recent decades, in recent 20, 30 years, the most common type of features used was so-called MFCC type of features. And to use those features calculated on short intervals of spoken language, to use those features to recognize what actually has been said. And about 7 or 8 years ago, completely new approach has been proposed. It does not require calculation of any type of features. It requires only to have a recording of spoken language and to try to train, in this case, neural networks, specially designed neural networks, to try to recognize. Obviously, this approach has clear advantages. What advantages? I guess you can easily guess which advantages such approach has. Because if you're using whole, not processed recording of spoken language, this will mean that you are using whole information contained in the speech. You are not losing any information. But of course, signal recorded has enormous variability. So for many decades, this approach has been treated as impractical, almost impossible to be implemented in real-life applications. But with the advent of first algorithm, authors of this algorithm, they were working at the company Baidu, but not in China, but in the United States, but Chinese company Baidu. They proposed approach called deep speech. Later, they proposed some new modifications to these algorithms, in some sense even radical modifications. They call them deep speech 2. Some minor modifications caused in the approach that they called it deep speech 3. But and this approach allowed to get very, very high recognition rate. Earlier, simply unimaginable. Some say that such recognition accuracy is so-called superhuman recognition accuracy, because sometimes this recognition rate is even higher than humans are able to recognize. To say the truth, I do. In fact, some studies says that in this case, it is possible to achieve recognition error rate on large unlimited vocabularies of spoken language as low as 2–4% of errors. To say the truth, I do not believe in this, because a lot of field studies, field evaluations show that, in fact, this error rate is significantly higher when you are trying to apply in real life. But in our case, what was immediately seen? That all those best results were achieved using very big speech corpora. Typically not less than 3,000 hours of speech recorded. Recorded and definitely, of course, prepared. And these results were achieved naturally for such languages as English and Chinese, first of all, because these languages has really enormous speech corpora, speech resources that could be used to train the systems. We do not have, and likely we will never will have, so big speech corpora which will be equal to 3,000 hours or even more, 5,000 hours to be trained. So in our case, for us, the first question was, is it possible to achieve really high recognition accuracy using those corpora that we actually possess? They are not very small, but of course they can't be compared with that 3,000 hours or so. We had corpora of 100, 200, even close to 300 hours, but not 3,000 or 5,000 hours. So that was one of our primary goals, to see how accurate speech recognition systems using this approach we can achieve. And for example, if those very promising end-to-end recognition systems could be also so promising for us as well. Or for example, other maybe more classical, I don't want to say simpler, but let's say it also this way, simpler methods could lead to even better results than end-to-end speech recognition. So the slide tells what I just tried to tell you, that actually those very high recognition accuracies has been achieved because of very big corpora were used to train our systems. What about Lithuanian, such language as Lithuanian? Problems of such corpora, many languages has 3,000 hours corpora, likely only, as I know today, only 3 languages in the world has, English, Chinese, and Spanish, only 3 languages. All other languages do not have so big corpora. So the algorithm in principle we can have, or we can use the same algorithm that were successfully applied for other languages as well, but sufficient resources we do not have, they aren't available, and maybe never will be available. So end-to-end speech recognition, as I said, is very promising because potentially it will allow to exploit all information contained in the signal. Now, what we did in this first approach, we essentially used deep speech 2 algorithm, which almost is one of, if not the best, is one of the best as officially is recognized algorithm, and trained it on 100 of hours large vocabulary Lithuanian spoken language. For the architecture, first we applied original architecture proposed by Baidu researchers, which had 3 recurrent layers. Each hidden layer has 494 neurons, while training has been performed using batch size 32. To say the truth, it was quite interesting observation. We tried to apply different modifications, but this modification was really one of the best. We weren't able to achieve significant improvement changing the architectures and going away from the original architecture. Despite that, we spent from 4 to 6 months only on trying to optimize the recognition method itself. It is not very easy task, despite we had not bad resources for the project we performed. But for example, one training took about 3 days. So 3 days, you need to wait while some set of parameters, some set of configuration will be optimized, will be trained, and after that you are able to check actual accuracy. Then you again need to wait 3 days if you will make 3 days, sorry, if you will make some changes. First was very small experiment. We used only 10 digits, but 10 Lithuanian digits spoken by more than 100 speakers. And those speakers pronounce each series of those digits. Likely not me. Okay, but those recordings were done in clean environment with moderate noise and with stronger noise. Signal to noise ratio was 15, 10, and 5 decibels. And comparing with the classical older model result that we had previously, which were obtained using hidden Markov models, the results were in all cases better. That made us happy for that moment, especially significantly better when applied for noisy signal. When signal to noise ratio was only 5 decibels, strong noise, you see, the results were really very not bad, while in previous cases you see noise had significant impact on that. For a moment we were happy, and then we went to apply the same approach for large vocabulary recognition. We performed all these experiments, of course, in speaker-independent mode, so means that we used naturally for evaluations cross-validation. 10% of continuous speech corpora was used for testing, and while another part, 90% for testing. And what we found, those studies told us that, let's say, original implementation applied of end-to-end speech recognition resulted in about 5-6% error rate. In our case, using that significantly smaller database, significantly smaller cost, we saw that error rate varied from 38 to 62%, while average accuracy was about 45%. Incomparably, results that are incomparable with those presented in studies which used significantly bigger resources. What to do next? Of course, those results weren't satisfactory, and it was one of our most interesting attempts. You know, most of the large vocabulary recognition systems are using also the grammar model. But to implement grammar model into end-to-end approach is task of, let's say, completely different task. Because typically, in typical grammar models, you need to have probabilities of words, sequences of words, but because this model works on raw signal, you can't simply implement word probabilities as in those classical, let's say, CDHMM models as well. Traditionally, in other studies, in studies performed on, let's say, on Chinese or English, grammar models in those situations were applied slightly differently. They used not the probabilities of the words, but the probabilities of the letters and sequences of the letters. For us, when we found those bad results, the problem was that we do not have model which could help us to find Lithuanian letters probabilities. We do not have such. So, first of all, we performed, of course, error analysis. The original text has, for example, in our case, 96,198 words as written in Lithuanian text, and which we treated as error-free text, while the output of the recognizer produced 94,489 words. So less words were at the output than was in the original text. So, how many differences between lexical units in original and generated text was? We found that there were 45,380 differences. That's why the number of errors was so big. So let's see why so high number of the errors was. Many errors were caused by simply improper splitting of the words or improper joining of the words. When you need to evaluate the error, you're comparing the written text, generated text by the recognizer with the original text, and you're, in any case, if one letter do not correspond in one text or another, you're fixing it as an text. But most of the errors were generated by the improper splitting or improper joining. For example, recognizer wrote the word visata meditacija as one single word, while you perfectly know that there are three different words. So after that, we applied then preprocessing to try to find from vocabulary possible words, and if it is possible to split or to join some words together, we treated them, we did this. So after such post-processing, the number of errors, number of the differences between the original and not original word text has been reduced to 40,784, still 42.4%, still quite a lot. Then the obvious errors with letters had been, because very many errors were caused by the fact that instead, for example, of one letter, another letter, similar letter has been generated in this text. So, doing several such processing, the number of the errors has been reduced from 44,318 to 18,332, which is 24/53% error rate. Still, not very good result, but significantly better than when the model you are applying as has been proposed originally. At the final stage, we try to apply some grammar modeling of that post-processed text. After post-processing, the grammar don't allow to increase significantly the recognition accuracy, because likely that post-processing already did many things that grammar will be able to do. So here is the final table allowing, that I want to show how post-processing of text can improve overall recognition accuracy. So without grammar, without original text, resulted in a 45.4% of errors, and post-processing allowed to reduce this error rate to 23.3%. This result is, of course, significantly better. It's not even close to that 4-5% that were obtained using huge resources. And here is one of the conclusions. My conclusions for this is that anyway, end-to-end approach will work best only if you will apply it on very big amounts of data. If you will have limited amounts, relatively limited, despite that 150 hours is not so small amount of data to train, this method will not work so nice. So now I will switch to another presentation, what we did to how we can improve these results. Because we had not satisfactory results with end-to-end approach. Also, another group led by Professor Reškinis at Vytautas Magnus University, they in parallel did another set of experiments, but they used not the end-to-end approach, they used LSTM-based approach. So then we thought about how we can, for example, to combine those two approaches as well. Maybe it is possible to achieve better results combining them two. But how? But how to do this? Could different algorithms be combined together to get better results? But how? Because each of those architectures has completely different topologies, has completely different sets of parameters, so it is not clear how to combine. So our approach was to try to set each output from each of those algorithms, from these two networks, and try to train some other algorithm, simpler algorithm, to select which output is at the current moment better. So that was our idea, try to train outputs of the recognizers to select which one is better. I need to say here that this approach is used only in the case when two different networks generates different outputs. If both generates the same output, of course, nothing is done. Only if one generates one letter, another letter, we are applying some rule-based method or some other method to select which one we need to use in that case. So, one of the problems that we needed to deal somehow in this situation was that those two recognizers also not resulted in exactly the same text in length. One had more symbols, another had more, and if you have two different texts with different number of letters, how you can train in which letter you need to compare which letter. So first of all, we needed somehow to normalize them, to make them equal. Identical, not in the text sense, but in the sense of the number of words and letters used. So we applied several rules. For example, how to do this, and as a result, here was the original results. We took 1, 2, 3, 4, 5, 7, eight different speakers. And here, for example, are the recognition accuracy for that particular speaker, applying LSTM recognizer and end-to-end. If you will see to the results, you here also will see that one of the observations is that LSTM approach results almost always better result than end-to-end approach. They were in both cases straight. So, after training some additional method to select which one is better, we applied, in this case, rule-based or tree-based methods. And we were happy that almost always, using quite simple training, the result has been improved. More or less, but almost always the result has been improved. So one of those observations, important observations in this case, I think, is that different networks has different potential to recognize different phenomena, acoustical phenomena. They're not equal, and this their parallel use has real sense. Not easy to apply, of course, because only likely this could be implemented in post-processing way on, let's say, on online mode. I still do not have an idea how this could be implemented because of the fact that you need to normalize, to equalize text somehow, and this could be done only when you have full transcription of whole recording after that. And after we made another group of experiments. In another group of experiments, we simply tried to reduce the number of the letters, to make the letters used in the text, because usually end-to-end recognizer generates typical letters used in the text. We tried to apply, in this case, a vocabulary which is closer to vocabulary of pronunciations. For example, instead of two letters D and G, we used one symbol, etc., etc. In this case, results were also slightly better, slightly improved. Maybe still not satisfactory, but still better. But also from these experiments, one important observation was as follows: where the majority of remaining errors were left. Why? Of course, in the situation when one recognizer generated some letter, another recognizer in that place left empty space, how you can normalize this? For example, one recognizer wrote the word toy, another toyo. So if one recognizer left this letter, left empty space in that position, we, to normalize this, placed always one symbol double. And there were significantly more symbols double there, empty spaces, I mean. And when training, obvious bias towards W, towards that artificially inserted symbol has been found. Yes, if not this, the number of those errors would be almost twice as, 2 times less. That's okay, that's, I am trying to finish. So the questions may be.
Yes. So thank you very much for the interesting presentation. So do we have questions? Yes, please.
First of all, thank you very much for your presentation and congratulations for your work. I'm not totally from this research area, but I'm just curious if your research and your work can eventually also be used for other problems on speech recognition.
I think yes. I think yes.
Because I was here, listening to you, and I was wondering, for example, the questions about age and the question about gender, that in some languages they are not balanced. So did you enter with these variables in your research?
Could be entered, of course. We tried not to use such parameters. Why? Because our main goal was to train the system to work with anyone. In our case, if you're talking about the gender, yes, we had a problem because among the speakers, males were more presented than females.
That is traditional in most of these words.
Yes, because most of the speakers were already selected among the students, so we had the situation that about 65% of speakers were males and only 35 females. How this could impact final results, I'm not sure, because in my last presentation, we analyzed each speaker separately.
Okay, but we saw that those results are not precisely the same for each one of the speakers.
Yeah, that's.
I was wondering about age and gender.
Age was more or less same, because all of them were student, and this was group of particularly special students, and all of them were males. That you see in these results, all of them were males.
Okay, thank you.
Yeah.
Thank you. More questions? Please.
I have a question on the hybrid approach. So if I understand correctly, there are two models which are combined with another meta model, which is in that case was random forest or decision tree, something like that.
Exactly the same.
How you do that combination? Because you have the output of, you said letters and words, and you have two outputs of letters and words, and then you need to combine them. How
We need to combine. So the idea is, if the two models generate different outputs, we're training the rule-based method using materials, which is better. Which is better.
Okay, thank you. More questions? Yes, please.
Thank you. So, as you mentioned that noise has lots of influence here, were those records of those students noisy or somehow especially unnoisy? As well, the first guess, how could the language be made less get more resources? I thought maybe it would be possible to use stenograms and recordings from Seimas Parliament, but then there would be also lots of noise. So
yes, noise is a huge problem. Usually, the corpora that we use were recorded in principle in silent environments. They had only natural noise and more or less equal. To achieve some SNR rate, we simulated adding the noise. But the noise problem is, of course, very big, because in the field conditions, you will not be able to control the noise, sorry.
Okay, thank you. More questions? If not, then I will ask. So
okay.
I heard that the breaking point for the English language is 1,500 hours, when E2E system is already better compared to hybrid. But what do you think about the Lithuanian language? Because we usually write as we pronounce. So theoretically, we don't need so many hours. Maybe with, for example, Liepa, we can solve this problem.
It could be, but Liepa is, now we see that Liepa is of bad quality as well. That's problem. But likely, yes, I can agree with you that 1,500 may be too much for us. Maybe 800 or 1,000 would be enough, but still the question remains open.
And one more thing, because you haven't said about that. It's, as I understand, it's easier to generate common words, right?
Yeah.
So how about the words that are not of the Lithuanian origin, like Facebook or similar words that are written a bit differently than they are pronounced? And plus, like in the English language, we do not have specific sounds like the sound or something. Do you try to deal with this, or the current speech corpus was more or less of the general
The current has relatively few international words, and as I remember, only words that, in foreign origin words that are used for many years in Lithuanian language were present, such as, for example, there were film, words such as film, but such new as Facebook, they're obviously not present in this corpora.
Thank you. So, if we do not have questions, let's applaud. There are 2 certificates for you. Vytautas, there are 2 certificates. Thank you. And as I understand, we do not have more presenters in this session, right? maybe I can give the word to you. It's from another session. So thank you very much. We are closing language technology session.
Thank you very much for sharing.
Thank you.
And we have, thank you for Professor Vytautas Rudžionis for solo show. Yeah, in this session is like, you know, we feel like in PhD thesis defendant's procedure, yeah, but two persons of articles can participate due to technical reasons, I think, and we have one participant from previous section which had technical problems. Can you hear us, Taras?
Yes.
Yes. Okay. So Taras, you have 10 minutes for presentation and up to 5 minutes for discussion. So the screen is yours.
Okay. So I try to share my screen. So my name is Taras Nanyuk, and I would like to present the paper Intelligent Method for Forming the Consumer Basket by Kristina Rykania-Anterenko, Karsten Wolf, Zeliana Czyżowska, Anatoly Sachenko, Taras Nanyuk, and Serhiy Brodsky. Nowadays, the method of calculating the consumer basket is an extremely important issue because of the basis on consumer basket is formed subsistence level according to which participation, social benefits, and payments are calculated. Based on the data of consumer basket, the consumer budget, such indicators are the minimum wage and the minimum pension are calculated. The value of consumer basket depends on level of retail prices for goods and tariffs for paid services, for example, utility bills and so on. The concept of consumer basket exists so sorry, I forgot to launch my camera. The consumer baskets exist in many countries around the world. People's purchasing power can change dramatically with respect to crises such as war and pandemics. Therefore, it can be considered that the development of an intelligent method of a consumer basket forming based on data from supermarket networks is relevant and allow to quickly change the sets of goods in consumer baskets and formation of subsistence level for prevent possible humanitarian economic disaster and increase poverty. The purpose of this paper is to develop the intelligent method of consumer basket forming. To quickly change the set of goods in consumer basket, the authors has developed an intelligent method of consumer basket forming. The proposed method is illustrated schematically on figure 1, and it is represented by following steps. So I go to figure and explain steps. Step 1, which is collecting of data from supermarket, it is block 1, namely information about the buyer ID, age, revenue, and buyer's purchase, transaction ID, date, list of goods, product price. When collecting data, it is possible to expand the database of pharmacies, food and non-food products. Step 2 is data clustering. 2.1, it is selecting of objects from clustering, this is block 2. Then step 2.2, defining the set of variables, this is block 3. which will be evaluated object on the same sample. Then we have normalization, calculation of values of degree of similarity between objects, application of method of clustering analysis to create groups of similar objects, presentation of results analysis, and step 3. Step 3 is description of obtained clusters, namely the definition of social cluster, is block 8. Also, the transfer of existing social clusters in a separate database, block 9, which will further automate the process of processing for cluster information. Finally, step 4 is consumer basket forming, which is block 10, and recommendation providing, block number 11. The Python language was chosen to carry out the intelligent method of consumer basket forming. Customer personality analysis data from Kaggle platform was used as input. Our students use this platform. This platform has some not full data, but it is enough for study of student. So this dataset presents analysis of client's personality. Data are presented in US dollars, amount spent over 2 years. The structure of data selected from dataset is presented in table 1. This data is not enough to fully solve the problem. Obtaining the complete required dataset is a difficult process. But as I said previously, it is used for some education tasks. It is important to have a complete list of purchased goods by a buyer so we can form a more detailed list. However, for implementation of developed method, the safe customer personality is enough. Normalization must be developed before clustering. We are also interested in knowing the cost per month, so we will divide all costs value by 24 months. This will get the values ready to form a consumer basket. Then clustering was performed. To implement this task, the method of Kamin's clustering was chosen because it is the most popular and simplest approach to clustering. In the following research, we will use other methods of clustering. To select the number of clusters, the elbow method is selected. This method is calculated as a square sum of the distances of the point from the center of cluster according to the each value of k. According to these values, a graph is plotted for each value of k. This point of elbow on the graph, where the difference between the result begin to decrease, is defined as the most appropriate value of k. For example, the optimal number of cluster is 3, as you can see from figure 2. Next, the considered visualization of the obtained 3 clusters. As can be seen from figure 3a, the cluster numbers 0 most customers. The interpretation, figure 3b, is the obtained clusters in accordance with the characteristics of income and total costs. Cluster 2 is high costs, average income. Cluster 1, high cost, high incomes. And cluster 0, low cost, low revenues. If we consider cluster as social, then it is important that cluster 2 and cluster 0 are considered. According to the authors, it is worth focusing on the customer basket formation using these 2 clusters, namely to form a customer's basket based on cluster 2 for an economically stable situation and increases situation based on cluster 0. When considering the buyer's age category on figure 4, it is seen that the distribution of clusters is fairly uniform. Therefore, the authors believe that the age does not affect purchasing power. Next consider is more detail in the cluster related to the amount in USD of purchased goods. It's for figure 5 for 2 years. Box plot charts best show the point of determination of the average number of purchased goods in the cluster. The results show that the cluster 1 spends very little money on fish, meat, sweets, and wine. However, cluster 2 shows larger amount spent on these goods. If we talk about technological products, then all buyers have approximately the same costs. It is figure 5e. Thus, in the term of goods sales, the authors believe that cluster 2 has the values that should be taken into account at the customer basket formation. So let's describe cluster 2 in more details and use it as the base of recommendation for the customer basket formation. Customer basket, cluster 2, it includes 27% of middle income customers of different age. Fish products purchased for the month in the amount of 25 USD, meat products purchased for 100 USD per month, sweets in the amount of 20 USD per month, and wine products for 400 of USD per month. So equipment is in the amount of 50 USD per month. It should also be understood that these results maybe not correspond to the real situation because there was not enough data. The proposed intelligent method of forming the consumer basket is based on the data from supermarket networks, enabling to change quickly the set of goods in the customer basket and the formation of the subsistence level. As the input, the customer personality analysis from CAG platform was used, presenting an analysis of clients' personality. This data is not enough to fully solve the problem, but they are enough for the implementation of the developed method. To implement this task, method of clustering CAMIMS was chosen because it is the most popular and simplest approach for clustering. From the results of clustering, it can be concluded that the consumer basket should be formed on the basis of cluster 2 and increases situation on basis of cluster 0. In the future research, we plan to investigate the method of predicting the changes of the customer basket formation. In addition, the cross-cluster analysis will be performed with different approaches to determine the best approach. Thank you for your attention.
Okay, we have several questions from on-site participants.
I want to clarify if the data presented in the table on slide 5 was in prices or some other expenditures or yeah.
In table, yes.
Yes, in table. Prices here, expenditures or some other parameters?
No, it was not a crisis in the table.
Okay, next question.
If you go one more slide back, there is a scheme which you use for your method. The scheme of your method, which had lots of boxes connected.
Which slide?
A little bit back, I think, in the first few slides was the illustration of your method, previous, in the beginning. Yeah, this one. So here I see the step 5, which is calculating degree of similarity, basically finding how similar the objects are, yes? So when you apply k-means, do you need this similarity matrix? Is it needed, this step 5?
Pardon, please repeat. Understand correctly.
Yes, you have step 5, which calculates the similarity, yes? And I imagine that could be important maybe for hierarchical clustering, which are based on similarity matrices. But for k-means, do you use a special version of k-means which consumes this type of similarity matrix, or do you need this similarity matrix in the step 5?
No, it was not a special k-means map.
You mentioned you use the k-means, so I was just wondering if this step is needed.
How similarity was implemented?
We use ordinary k-means method, and we use it in Python.
More questions? Okay, we do not have more questions. Thank you very much for presentation again. Let's applause. So, thank you very much. And okay, so we completely show the section number 4. The last presenter presented his work and his results. So thank you very much. And now we have half an hour. Now we'll have half an hour time break. Not half an hour. Yes, half an hour time break. And at 3 p.m. we will start with special session on smart e-learning technologies and applications, and the session will be chaired by Professor Dr. Jan Andone. So, okay, it's time for coffee break. Thank you.
welcome everybody, and I'm really very sorry that we haven't been able to meet all of us more in person before, but I'm very happy that we are not here in the Kaunas University in the Faculty of Informatics. I'm Diana Andone. I come from the Polytechnical University of Timișoara in Romania. I'm the chair of the e-learning session, and I will try to support you as much as you can during this session of presenters. Without further ado, I will kindly ask Yukita Svariniene. I'm so sorry if I will say wrongly your names, but I'm not very good with that. So I will let you to introduce the other authors. So I don't want to make up with Asta and Dina. Dina, I know her name, Kudoniene, but not the others. Daunoriene. So I will see the paper on technology-enriched challenge-based learning for responsible education. So you have about 10 minutes, please.
10 minutes,
Yeah.
okay.
Because we already have some more papers and so on, so if not 12 minutes, but that's maximum, okay?
Okay, thank you very much. I will try to do all my best. It's my pleasure to be here. I am Jurgita Barinene from Kaunas University of Technology, and today I would like to present our research findings, and this research was made with my colleagues Asta Daunorene and Daina Gudonene, and you really see what we are very multidisciplinary team, so it very corresponds with the philosophy of challenge-based learning. So the aim of our research was to analyze how technology-enriched learning really can ensure the successful implementation of challenge-based learning in all study process. We used such research methods as analysis of scientific literature. Also, we enrich our research with case study. And during all research, we have two main questions under consideration. So how challenge-based learning and all philosophy of challenge-based learning really correlates with responsible education paradigm, and how can technologies really can be involved in challenge-based learning and help to reach learning outcomes in all study process. So my presentation, I would like to start from the concept of responsible education. Really today we are talking a lot about educational transformations in nowadays societies, and responsible education talks and have wider goals of education. We talk not just about knowledge, about skills, but also we involve changing values and changing attitudes in nowadays society. And a responsible education really would like to equip our students with needed skills, attitudes, and values, and to help them to become chaos pilots and to act in this context of uncertainty and on the context of unfamiliar context. So today in our labor market, we really need the students with orientation towards the future, not talking about just individual, but also about collective well-being. And really we need to learn, and as academicians we need to teach them to navigate from that unfamiliar context and to find direction in the meaningful way. So here's just a reminder of our 21st century skills. Here we really talk about the challenge for educational institutions, what we really need to prepare the students for jobs and technologies what don't yet exist, and to really solve the problems which we don't know, like the problems yet. And here in this context also erects the T-shaped professional idea for future approach of our graduates with deep functional knowledge, deep knowledge in discipline, but also the broad set of our transferable competences in our graduates' competence combination. So talking about skills for the future, we really talk about human dimension, about leadership, about self-authorship, about multicultural education, teamwork, citizenship, and so on. And here we really came to a theoretical approach. What responsible education involves stakeholders and all community. Analyzing all social, economic, and environmental problems, we really talk about equipping students with knowledge and skills for what purpose would they be active citizens and responsible citizens, and find long-lasting solutions here. And here the idea of challenge-based learning really comes because this method really very corresponds with responsible education, and usually it has a very chrestomatic process. We have three stages. We have stage of engagement, we have stage of investigation and of action. And here in this all process, we talk about learner-centered approach, and this challenge-based learning all approach really helps us to equip our students with that skills about which I talked before in the slides, with creative thinking, communication, collaboration, time management, critical thinking, and so on. And challenge-based learning for responsible education really seeks to address and solve specific challenges which comes from real life conditions and context also is taken from stakeholders and require a really high degree of interdisciplinarity. And going wider, we really decided to analyze how technologies now is everywhere around us, how we can help for challenge-based learning in class and, for example, in distance learning. And really we see there are main prerequisites for effective challenge-based learning in distance learning. And here we see what we need: access to the infrastructure. We need really what our teachers and learners receive a technical support on time, some communication basics, online collaboration basics, and so on. And when we think about all challenge-based learning process, we really see what technologies can help here a lot. For example, in engagement phase, when our learners really trying to get to know more about all the context, technologies here can help with communication with stakeholders and community. Also, technologies can help our students to raise essential questions and to answer essential questions using open databases, open educational resources. Communication between students can also be easier, and also with teamwork in order to make our all learning process more sustainable. For example, not to use flip charts, but to use collaborative environments online. In the investigation phase, here also technologies for us can help our learners to answer the research questions. Also, there are some techniques what our learners raise guiding questions which can help them to solve the challenge. And when we categorize them and prioritize, so technologies can help here also. And in the action phases, which is very important in challenge-based learning, because our learners really not just come up with solutions, but we also try to implement that solution in the real world, in the real context. And here we also have the help of technologies. What we can create the prototypes, digitalized prototypes, and also technologies can help them to communicate with users and clients. Another very important thing in all learning process is feedback. And feedback also can be given more smoothly using technologies. And different types of feedbacks: educators to students, computer to students, peer-to-peer learning, self-feedback also can be supported by technologies. And also, as I mentioned, we enriched our all theoretical research with our case study. We analyzed 6 modules which was provided at our university at the period from 2019 and 2022, and each course had more than 20 students, and we analyzed which technologies or which tools, technological tools, was used during challenge-based learning application process. And here you can see the broad menu of that technological tools and activities, CBL activities here. And we saw what, for example, for communication, more usually was used Zoom, Team. Students, when we communicate between each other, also use Facebook very often. For work organization, mainly students used Trello platform. For research, we use Google Docs, MOOCs, Mirrorbot, also Google Forms. Prototyping are usually was done using CAT programs, and also Scratch, ThinkHard. Another very important processes in challenge-based learning, like sharing, documentation, feedback, and reflection. For example, for reflections, what is very important in challenge-based methodology, what students and learners can all the time reflect inside the team, reflect with teachers and with stakeholders. Here also technologies were used very often, such like Jamboard, also Google Docs, Mirrorbot, Mentimeter, and also Google Form. So, and coming to the conclusions, really we saw what technologies can really be very effective to promote all challenge-based learning methodology and online mode, and also in regular classes they also can really help us to be more sustainable. Students actively use different technologies to solve challenges, and in very particular places when we are working with challenge-based learning methods, when we communicate, when we work together. Also, we saw from the research what teachers do not necessarily have to be technologically experts in challenge-based learning course, and students take more responsibility to choose right platforms, which is really more convenient for them. And challenge-based process could be really very immersive by using different technologies and rewarding students to use these technologies and to solve that real-life challenges and to make them more sustainable in the long perspective. So, hope I managed the time.
You've done very well. You have
Thank you
20
very
seconds
much.
left. So I think we have time for questions. So
Thank you very much.
Thank you very much.
Thank you. I am open for questions and eagerly waiting for them.
Yes, please, questions if you have any.
So this 20 students, okay, so it was the one group and they work in all these courses or smaller ones?
Yes, we worked in smaller groups. It's what it were 20 students per one module, but of course we was divided into the smaller teams, and usually it was about 6 students per team. We really saw what is the relevant and good number for the teamwork and challenge-based learning.
Okay, I have also a question. I quite like your third dot there, that the students take on most of the responsibilities. We have done quite a lot of the studies, probably in the last 15 years, saying that with the level of technological advance, so how well and how comfortable they are in the technological of the digital world, how much they want to have control, they have even more control, and they don't like interference. But again, the studies shows that too much control is very disturbing, because then it disturbs to them from the learning. They spend too much time on deciding what tools is the most appropriate one and so on. What was your finding related to that?
talking about challenge-based learning, the philosophy of challenge-based learning is to give more responsibility for the students and to give them the possibility to fail in one or another situations. So really, yes, your remarks are very good, but here we should take all the process as the learning process. Here we learn, and we learn how to choose that technological tools and how much time we spend on that methodology. So really challenge-based learning, it's a lot about ownership and about responsibility which can be given to the students. And teacher just help them, just guide them, just coach them in this process.
I'm just pointing the microphone because I've seen some remarks that we are not always heard. Thank you very much.
Thank you very much.
Thank you
it
so
was
much.
my pleasure. Thank you very much. Thank you.
Thank you. I will kindly ask the second authors. So I will kindly ask the second authors of the second paper, which is Open Course Integration into Formal Education, Case on Database Courses, which is written by Rita Butkiene, Linas Abloniskis, okay, and Algirda Sukis. Shukis, okay. As I said, I apologize in advance. So please, the floor is yours. Algirdas, no? Algirdas, okay.
So, good afternoon. I'm Algirdas Shukis, and I would like to present you our paper, Open Course Integration into Formal Education. We wrote this article because we wanted to share our experience of applying flipped learning methodology.
Speak louder because they need to hear them. If not, keep this. Keep this.
Okay.
That's fine. No, up to you. Up to you. Like
Okay. We wrote this article because we wanted to share our experience of applying flipped learning methodology for a traditionally taught module. So my agenda, my structure of presentation is presented in this slide. Firstly, I will present the databases module that we teach. Then I will introduce MOOC, what MOOC was created and how we redesigned this course. And then I will present the analysis of MOOC usage, and finally I will conclude with some insights. So some information about databases course. Its length is 6 credits, and it is delivered to second-year bachelor students studying computer science. And most instructors have more than 10 years experience, and most of them also have an experience of designing database or programming databases. And each year we have at least 300 students. And the topics of this module can be divided into 3 parts. First of all, students learn entity relationship modeling, and next topics about relational data model and database creation. And also this course covers SQL basics and data input and review forms. So by learning students, we faced some of the challenges. It's not something very exceptional, but there are problems with keeping attention of students during lectures, because lectures are long and students are hard to keep attention during all the lecture. We ask students to take some tests during lectures. It helps to maintain their attention, but only a little. And another challenge is that some students choose not to attend lectures for various reasons. And another challenge is adjusting to different student aptitudes. It is when teacher has to balance between giving more attention for struggling students or going further with those who can learn faster. So we decided to redesign the databases course by creating MOOC, but we decided to include topics not from all the course, but only topics from entity relationship modeling. Because first of all, we wanted to see if this methodology works for our students. And we choose entity relationship modeling because we thought it would be a good idea to present main material as video lectures and face-to-face as videos, and face-to-face lectures use for more student engaging activities such as solving modeling tasks, discussions, and so on. And also students could improve their overall grade of databases course, but only with the very little impact by attending our MOOC. So the course is presented here. We decided to present the material of entity relationship not in one large video, but we decided to divide the whole course of ER modeling into 11 topics, which can further be grouped into 3 groups. And the first group is entity relationship modeling basics, where we introduce the notation of entity relationship modeling. The second group of topics cover modeling, where we present complete, present, and describe complete entity relationship models. And the last group is typical cases, what covers such topics as modeling changes in time, categories, and hierarchy. And for each of those topics, we created a video, which is about 5 minutes long. And it was mandatory for students to view videos of all topics. And students could view videos for an unlimited number of times. Then after viewing video, a student could take a test and to see if he learned the topic well. Most tasks were drag and drop type, where students have to move elements to the correct positions in the diagram and to complete the diagram. And finally, students could take final task and final test. Final task is when students were given a description of business domain, and they should draw entity relationship model of that domain using their favorite modeling tools such as Magic Draw. And final test, they had to, taking final test, we had to prove their knowledge by answering, by solving tasks of the whole course. So after students completed the MOOC, we analyzed the usage data, and the goal of analysis was to find out whether students were active and also to identify parts which should be improved, and maybe they were too complex or too easy for students to solve. So the first question we wanted to answer: how many times did the students watch the videos? In this diagram, you can see bars, and each bar represents a topic, and the color means the percentage of how many students viewed video of that topic. And we can see that orange color dominates. That means that most videos was viewed by only one time. And videos of topic 5 and topic 6 was most complex, and they required 5 or 6 views by the biggest percentage of students. Another question is how many times did students needed to complete test, and here we can see that test 5 seemed to be also complex because it is related with entity relationship. It contains questions where students had to drag elements and to complete entity relationship models, and test 2, 4, and test 10 also contained similar questions which needed not only knowledge but also logical thinking. And so in this slide we can see the analysis of course usage. It shows how many videos students watched. The diagram in the left indicates that 81% of all of students watched all 11 videos, and 4% of students did not watch any video at all, and they were active. Again, I can repeat that to get a possible grade in this course, students had to watch all videos. And in diagram in the right shows how many tests students completed. And here we can see that only 41% of students completed all 11 tests. And then it's interesting that 40% of students completed from 5 to 7 tests, and they had motivation in the beginning, but they didn't manage to complete all the tests for some reasons. And this is a graph of how students took final activities. Again, final activities was not mandatory, and if students watched all videos, they could take those tasks. And we can see that about half of students decided to take those tasks. And the video in the right, this shows that many students completed the final task by 2 attempts, and completed final test only by 1 attempt. That means that completing final task helped them to prepare for final test. After completing the MOOC, we asked students to take a questionnaire, and 77% students said that about their satisfaction, that they are satisfied or very satisfied with the course, and 18% rated their satisfaction as average, and also 64% rated the length of the course positively. They also could say positive or negative points of the course, and students liked short videos, they liked consistency of topics and transitions between, smoothness of transitions between topics. And as a negative point, some students stated that final task is too complex, or there are too many questions in test, and some multiple choice questions also were complex. So in general, we can say that students liked the idea of dividing the large course into smaller topics and presenting the material as using short videos. And we noticed that about 5 minutes length is acceptable for students. And also analysis of MOOC usage allowed us to identify topics that are too simple or too complex, and they should be revised and improved for the course of next year. And only 41% of students passed all the tests, it might indicate that many students are not fully motivated to master the topics as well as they can, and they are satisfied with the minimum possible grade only. So, thank you for your attention.
Thank you. If there are some questions, please.
Yes.
Yes, actually, two questions, very short. First of all, do you have any results from previous years regarding the obtained results and also about the well-being of students between the traditional method and this one?
No, unfortunately, we do not compare, for example, grades of previous year and grades of this year.
Okay, but besides of grades, I was thinking if you have any other methodology for assessment of well-being of students, like questionnaires or something like that. You do not have to compare at this point.
No.
The second thing is just a personal opinion from you, that did you feel that those 40% of students are the ones that naturally are already engaged on the courses, which means that we are thinking about all these new ideas only for the same students, so the ones that we already know that are engaged? Do you have any feeling about that?
Well, as you see that about 80% of students watched all the videos.
Now I was thinking about your final comment on the conclusions, because you said only, in your words, 40% of students did everything until the end, which is also the same practice at my university. We always see that there are some students that, I will say, I'm sorry for the present people, there are students that we cannot save. Whatever we do, we cannot save them because they are not motivated at all. And I'm afraid every time that I follow these ideas, and I was asking your personal opinion, if we are not always working for the same group of students that are already motivated beforehand. Do you have any feeling about that? Or it's not easy to assess, I know.
I know it's not easy, but some part of students are not motivated, and we can do whatever we want, we do.
Yeah, I know. Okay.
We cannot.
Okay, but congratulations for the idea. And, well, I like it very much. Thank you.
Okay, so thank you very much for this. As I do a double job, I speak loud enough. I'm used to cover 500 students in a room, so it's not a problem. I can even raise it more, so I don't need that. So thank you very much. I want to give you this, because this is why I was coming here. So this is yours. Thank you so much. Congratulations for this. Thank you. So I'm doing a double job, and I will start the presentation of a paper, as I have also my colleague coming live soon, and I'm very pleased to be able to present the ways of recognition. Yes?
You need to share your screen. If you will do the presentation with your colleague.
Yeah, I will share that now.
Yes,
okay.
Yes, yes.
Can you help me, please? Where is the algorithm? Okay. Hello, Hakan. We see Hakan. Hello, Hakan. No, let it. No, because it's not selected. Select this.
No, you need to share the screen.
The whole screen.
Yes.
Okay.
Yes.
We are doing picture in picture.
Yes. Just give it some time. Yes, here it is.
Perfect. So I hope Hakan can hear us and see where I am with the presentation now. Thank you very much for your help. So this is a paper which is co-written by several authors. I'm very pleased to say that other two of them are in this room. which is Rita and Dina, myself and my colleague Vlad Mihaescu from Timișoara, and Cengiz Hakan Aydin, who is now online, coming live from Turkey. And we have also... Thank you very much. And we have also our friends from Germany, which are the leader of this project, Tim Bruggemann, and also our colleagues from Portugal, Carlos Vaz de Valar. So this is a result, quite a final result, if I can say that, of a project which we ended just about a month ago, in fact, and which is an Erasmus Plus strategic partnership between all of these partners, led by Fachhochschule der Mittelstands from Germany, and all of us, we are partners in this project, which is about Mod IT. And I just want to give you some information about the project first, obviously. Mod IT idea was about curriculum modernization following MOOC procedures and MOOC pedagogy to be brought in higher education, and especially in technical higher education. So we had quite a lot of these ideas of how to do it. I will need to say thanks for Dina, because this is a project which was her idea many years ago and finally successful for funding, so we managed to get it and to have it done. What we have done in this project, more or less, is here. So what we have done is like we established an online self-assessment tool, which was the tool which helped us to really be able to assess the level of instructional design needed for online education for our higher education professors. Second, we've done training. We had more than 25 and then another 25 professors which were trained on MOOC pedagogy, so massive open online courses pedagogies, into how you bring them in higher education. Then we done a redesign of some curricula, and I think the database course which you've seen is a result of this project, because that was one of the courses which was redesigned completely based and following the MOOC involvement and MOOC ideas on the curriculum. So these are the things, and this is how we have done, and obviously a pilot and evaluation. I just want to direct your attention to this course because this is still freely available, and I would kindly encourage everybody to go and follow it because it's very valuable information which is here in OpenKTU, but also in Iversity. So you have two versions where you can go and watch and see the project result and see the course and learn mainly how to use open and online education principles into traditional higher education and how you can change and adapt your curricula. So we had 125 partners. This was the only slide where I could find with OpenKTU Edu address. So that's the address where you can find the slides. It's not advertising, it's just that. Now about the paper. So this paper is trying to see mainly what we can do in terms of recognition, academic recognition from the MOOCs. And you will see that there are different ways of doing it, and you can really do a lot of small changes in your curriculum and in your course delivery, which has quite a lot of impact on how you can really have that for the future. So these are the, what you will see here are some national cases of this experience of the online courses recognition, and then also some ideas about the literature and what others are saying about that. And these are cases which are coming from Lithuania, Germany, Turkey, Portugal, and Romania. So these are the principles. This is a summary of the principles for recognition in academic recognition of the MOOCs. And as you can see, the most one is this one, which is also academic and professional credits awarded. Why? Because this is when it's also university involved. Like for example, I will take an example, Cambridge University or Delft Technical University, which has their own MOOC platform and MOOC structures of courses in FutureLearn, for example, or in edX. Then they will fully recognize the courses which are also run in a MOOC platform, which is an open source platform, or an open access platform, plus the same course, they will run it in the same time with their students. But that's only the case for those who are fully involved in MOOC delivery and MOOC creation, which is sometimes the case for Kaunas, for the courses which they have done. You just seen previously an example of that. The students needed to be involved in MOOC. That was a prerequisite to get into the exam. and to do the test online, so to finish, in fact, a MOOC before doing the exam in room. So how we can do that, and what are the principles which are based on the literature? As you can see, sometimes we always consider that ECTS is, a way of gaining academic credits, which we consider more as quantitative. But there are also qualitative, information and data which is hidden into ECTS, because they also look at the way of assessment. So sometimes it's enough to change the assessment way, and it's already changing the entire structure of the curricula and how to deliver these one things. And then, obviously, that assessment can be different. You can recognize part of the prior assessment or prior knowledge or activities like Rita and the colleagues from Kaunas and us do. So the student does half a course as a MOOC online, and you recognize that, or completely as it is, and then you just do half of the other course or other activities or an exam, which is following exactly the initial curricula and the traditional one. Obviously, MOOCs are very famous for microcredits and for badges and for the recognition of the skills which you gain from informal training. One of the biggest, successes of the MOOCs is due to this, that they are compatible with work life. They are modular, they can be changeable, and they are online and on your self-paced. So you can do it when you want and how you want it. So, and they're usually quite low cost in terms of numbers. So obviously, if you only have 50 students, then it's not low cost. Something about how we are doing it now in Romania, we follow these three models cases. One is where we have full recognition as ECTS credits, usually for practical placements, for a lot of other activities, or like, for example, in master students, we have the research, management and research project course, where part of the lab is recognized because they follow 2 or 3 MOOCs online and so on. So a lot of that. Then it's obviously you integrate that completely in your course, which is the most common way of doing it in higher education. And I can say that it's the most easy one to do it because it doesn't require all the paperwork for changing the curricula and the accreditation. And then some of them which only use it as resources. You point for the students, okay, these are these courses, like I pointed to you, the Mode IT courses, follow them and do something out of them. This is, for example, how we do it also in, in the university. And for example, we have done some studies in the university, like over the years, and we realized that several of our students said, that our experience of doing it online is much better, and they enjoy the interactivity and the accessibility and the flexibility of doing the MOOCs. And now I will let Hakan. So Hakan, the floor is yours. You can unmute yourself and let me drag you there. So we can see you now.
But he won't be able to change the slides.
I will change the slides. Oh, okay. You can unmute you.
Hello, can you hear me?
Yes, please. Carry on.
Yes. Hello, everyone. Thanks, Diane, for the introduction of the project and the partners. I'm Cengiz Hakan Aydın from Anadolu University of Turkey. I wish I was with you. I wish I were there with you, but unfortunately I can't come. In our study, Diane already has drawn a big picture about what we did. I would like to now present some of the use cases that each partner is implementing in our institutions. First, about Germany. Germany has this name. They gave this name, Pick and Study model. This is a way of integrating MOOCs and recognition of the MOOCs into formal curricula. It's a real modular study program. People can choose what they want to learn, especially this study designed for the professionals who would like to upgrade their skills or reskilling their, for reskilling. They can at the end earn, sorry for the for the mistake. They can earn ECTS credit, ECTS. And if they enter a regular program, they can use those ECTS for their formal programs too. Majority of the courses in this pick and study mode is self-paced courses. So people can learn by themselves with their own pace. At the end, they can receive a certificate of attendance or a university certificate. But in order to get a university certificate, you have to be a formal student in any program. You have to be formally pass through all the regulations, all the registration processes, and become a student in any of the program. Then you can choose pick and study program, take some courses, and at the end you can get a university certificate. But in order to get university certificate rather than certificate of attendance, you have to take a regular exam. It is conducted either online or on-site, but you have to take this exam to be able to receive the university certificate. But in terms of certificate of attendance, all you have to do is you have to take the quizzes at the end of each module, complete those, and get the grades. But you have unlimited number of chances to take those or retake those courses. So this is the Germany case. Although you are from Kaunas, I mean, maybe Diane would like to, or Rita would like to sort of present this part. But let me give what I have understood from there regarding the Kaunas side. Kaunas has a MOOC platform. I like the name actually, OpenK2U EDU. And our course is also there. So if you like to take our course we created during this project, you can access through that part, or as Diane mentioned, it's in iVersity too. As you see in Kaunas, the MOOCs are mainly used for virtual mobility, especially for international students, Erasmus students who would like to come to Kaunas, first take some courses here and get acquainted with the education system. Plus, they might get some ECTS at home, especially where students can take some online courses through, again, this MOOC platform and gain ECTS. This the MOOC platform at the same time is targeting the continuous professional development. Sure. Oh gosh, I don't know. So this is, as you see, in terms of recognition, it's based on the MOOC requirements. Based on, again, if the MOOC requires an exam, you have to take the exam. If not, some assignments, you have to complete those assignments. If you move to Anadolu, I can give more information about Anadolu. Thank you. Can I? Yes. So in Anadolu, in Turkey, there is no legal or institutional policy. Unfortunately, just recently, especially with the macro-credential movement, the Higher Education Council, the institution that takes majority of the decisions regarding universities, is working on some policy documents, but they are not finished yet. But still, we integrate MOOCs into our formal courses. One way is the professors are free, or the teachers in the university are free to integrate any formal, any kind of MOOCs into their courses. They have to choose, then they can give credits for their for the students' efforts for those MOOCs. But of course, it is the responsibility of the professor, so he or she has to decide what kind of MOOC, what MOOCs, from where they can take it. Also, we have a platform, on an academic platform. If you go back, please. I know I don't have time, but just briefly. It's a MOOC platform. We offer some Turkish courses, MOOCs into Turkish. And in terms of recognition, we just provide certificate of completion. And we use it mainly for these courses. We use majority of those courses for remedial instruction formal courses. In terms of Portugal, they are sort of just at the beginning. We can move to Portugal, Diane. Yes. Porto, actually, they also didn't have any regulations, so they are having some difficulties, but our project helped them to think about recognition and integration of MOOCs. So what we learned regarding this project is simply 3 lessons we took. We can sort of summarize our lessons. First of all, shortage of awareness. If you move to next Diane, please. Yeah, the institutions and government bodies, they have no idea about MOOCs and integrating or recognition of MOOCs, and they are very suspicious about integrating those. So we need a lot of awareness to be able to extend the recognition and integration of MOOCs into the formal curricula. Also, we need policies and regulations. We have to have we should have institutions to develop that kind of regulations. And it seems that it is so much easier to integrate MOOCs into those informal, non-formal learning experiences. So we should think about integrating MOOCs into those certificate or that kind of programs. Very much. This was a picture, short, brief explanation of the cases, but we have more information. If you'd like to learn, please do not hesitate to contact with us. Thank you very much.
Yes, I just wanted to let you know at the end about these are the courses which were redesigned. So these are the courses which really helped quite a lot of our students nowadays to learn probably better, as you already have seen from the previous paper. And this is the whole partnership. So you can all see us smiling online, as we had half of the project online, even more than half of the project online. So thank you very much. And questions now, please. And I will stop the share. And Hakan, you are also on the screen. So we can take questions, both of us.
Sure, thank you.
I'm sitting down so you can see me. Yes. Questions? I have a question for you, Hakan. I'm the chair, so I need to have questions. I'm always very good at that.
I was expecting more from you.
Okay, so my questions for you is, do you really see a future on MOOCs being integrated in higher education?
Yes and no. This is a very political answer, I know. Well, the thing is, yes, there's a huge future and huge potential, but it is up to the institutions to take benefit of MOOCs. Unfortunately, there is a big lack of awareness about this potential. So we have to, as educators, as the advocates of MOOCs or micro-credentials, we should develop some projects to create or extend the awareness of the value of integrating MOOCs into formal curricula. Thank you.
I'll see how we can do this much easier, which is a case study on gaming implementation for social inclusion and civic participation. And I will kindly ask our next speaker to be here and to present. I will leave the Can you come and be sure that he's... I just want to be sure that you are sharing it correctly, because I'm not very sure how they do it.
Okay.
Okay. Good. 12 minutes, Grace. Or 30 maximum. I know.
Okay. Something completely different, so to speak. Good afternoon and welcome. My name is Peter Fruman, and I'm here on behalf of the in-game project. It's called Endgame, which we'd like to call a case study on gaming for social inclusion and civic participation. It's an Erasmus Plus project funded by the European Union, and it involves institutions from Spain, Romania, Greece, Lithuania, the Netherlands, Cyprus, Italy, and Poland. So before I start my presentation, I just want very shortly, each of you think for 30 seconds of an issue you want to be solved, you want to have solved in the short term or in the long term, and tell it to your neighbor to your right side, who's sitting right next to you, and vice versa. So I'll give you 1 minute. I'm stealing 1 minute, Diana. Think of an issue that's important to you and you would like to change. A small one, the environment, the world, whatever. And tell it to your neighbor. I see some telling, but not all, but okay. So, well, keep these issues in mind. So during the first year of our project, we had done extensive inquiries into current problems, concerns, needs, and desires present in the partner countries, sometimes with surprising results. For example, in my country, the Social Cultural Planning Bureau, an independent think tank advising the government, noted that very little had changed around gender equality and fair education for all in the last decade. In the end, the combined report of all partners revealed these 6 issues as the most urgent ones, which were, where is it? Gender equality, education, social inclusion, urban life and its future, climate change, and big global issues and the threats of opportunities which are in them. So this order of appearance is not a coincidence, you will see why. So anyway, this is quite a challenging list for the development of a serious game when we look at our main target audience, which are young adults from 16 to 30 years old. But it's not only young adults that we are addressing with the game, also educators who are working with young adults and maybe using that game as a discussion starter or a starter for a project. A serious game that doesn't sound fun at all. It doesn't have to be all fun, as long as it is challenging and offers engaging information and interaction, which was a challenge for us as well. Because as far as we know, a game like this does not exist yet. The issues mentioned cover amazingly accurately what we as societies have experienced in the last 2 years, and for many of us quite some time longer. And it won't be solved in the short term. What have we learned? What can we transfer? And how could the upcoming generations learn and benefit from that? As you can see, I'm a baby boomer, and I'm very much aware that my generation and Generation X have consciously and unconsciously not really done the best to leave a safe and healthy world for upcoming generations. So the next 5 to 7 generations are burdened with a lot of cleanup work. And that's an understatement. And we will probably not be remembered as good ancestors. The question is, can we plant the seed of good ancestry in the current generations, the 16 to 30-year-olds? And this game should confront and at the same time inform the current generation in an entertaining and engaging way, and letting them discover possibilities, solutions, and also hope that the tide can be turned to some extent. So how could we transfer knowledge, information, assignments, and trials without becoming too highbrow or academic, meaning long, boring texts? Of course, we had to stay away from that, although sometimes we had to share substantive information, serious information, Because a serious game, and especially with the issues mentioned, is about more than just problems and solving them. It's also about taking time to reflect. It's not easy to find the right tone of voice when you talk about big issues. And it is challenging to find the right visualization. When do you have to be serious? When is it appropriate to make a joke? How often do you have to frustrate or confront and still keep the player engaged? The generation we address is game-wise, used to immerse themselves in 3D, mythical, and alien worlds, or plain one-issue environments. They have learned to survive with trial and error, rewarded with skills to overcome. They are used to collaboration in multiplayer universes, searching for information themselves in these given environments, choosing their directions and initiating action or interaction. So will we be able to seduce them to play? This game, well, its avatar will only have its own wits and readiness to learn, to absorb information, and go to work within the real world, because our themes are real, and from the real world, an objective and subjective reality. A game is play. We all probably know that through play, individuals, be it an animal or a human, already in early life find out what works and what doesn't, individually and socially. Finding out about themselves and how to respond to others, how to respond to challenges and threats, trial and error. The same would count for developing a game. So how did we start? So first, the more technical and mechanical agreements. To start with, projects like this have a limited budget. There were no millions to spend. But of course, we are happy that we have been funded by the Erasmus program and be able to develop, hopefully, an innovative game concept for now. We agreed that the game would be a two-dimensional puzzle game in platform format with a single player moving from environment to environment, and within these to different sub-scenes. The player would control an avatar. There would be other actors, like a mentor and extra characters with whom the player will be interacting, all NPCs. There would be theme-related backgrounds, sometimes including hints, and there would be clickable and sometimes interactive objects. The game should be available on different devices, not only on PC, but also on mobile devices. We developed it using Godot, a free and open source game engine. It uses WebGraphs library, JavaScript API for rendering interactive 2D and 3D graphics within any compatible web browser. The first pilot version has been developed for the web. However, it will be easy to export it to Android and iOS. We have followed an iterative approach to develop the game. The technical team followed an agile methodology to develop the game, considering the comments from the partners and feedback from users collected into tests at 2 universities. Now, the game narrative is a coming-of-age journey of a somewhat humanoid youngster refugee from outer space who has found our planet in search of oxygen-rich environment. Hidden in an orb-like shell, he quickly senses that humans are rather suspicious and some even hostile. The shell is opened by curious Meister, who offers to introduce the stranger to this world and its inhabitants. Meister offers to be the mentor and is also the one who will introduce the avatar to issues, will explain some, will challenge, and when necessary will nudge the player into interaction and cooperation with other characters. So after passing through every level, the player or avatar has to answer some questions, it's kind of assessment questions, gets a badge from Meister and some rewards when he passes and can move on to the next level. By the end of the game, the toddler will have grown into an adult person, adult individual, not person. So now the game. So this is our intro. Ta-da. Why doesn't it work? It should go. Oh, here. Okay. Next slide.
No.
No?
In the middle, just press it in the middle.
For millennia, the Wads had been living peacefully and innocently on a planet called Urgens. Suddenly, one day a blue flash destroyed everything on their planet and made life impossible. So they had to leave everything behind and find another place. They fled in small orbs to many planets across the universe. In vain, because they needed oxygen. It was a bumpy journey. But some found a planet with an oxygen-rich atmosphere. It was populated with a lot of livestock. One species, called humans,
was with many, but they were afraid of alien life and tried to destroy it. One Wad survived, but as much as it wanted to learn how to live on this planet, it was afraid to get out of its orb. So it waited.
Level of the game has obviously objectives and learning outcomes. So the first level
For millennia,
No!
the Wads had been...
No, okay. The first level is gender equality. In this level, the player has to find out and learn about the difference between sex and sexual orientation, and gender, meaning gender identity, gender roles and gender norms that can lead to inequality, stereotyping, discrimination and exclusion in social life and the labor market. The second level is education. Education plays an important role in the knowledge of the world, in the development of the self, one's identity, self-esteem, and more. In addition, it's also about an individual's social or cultural background. And we also have to understand that equal chances are not as equal as we think. That goes for society in general, but specifically for education. The player has to become aware and care about the difference between equality and equity. The player will also find out how cultural and social backgrounds, political and social trends, and prejudices shape the whole education process. How they influence self-perception and self-esteem, which determine where and how you define your place in society. In the role of a teacher, the player should develop empathy with other young learners and acquire an increased understanding of the right to a good education for everyone. The third level is social inclusion. In this level, we want the player to become aware that social exclusion, including stigmatization, stereotyping, discrimination, and racism, can happen in different places. On the labor market, in the participation in communities, in policy and service institutions, in social media, in legal norms and rights, in informal community norms and practices, and in basic human capabilities and disabilities, in dealing with others. The player will experience moments of exclusion and will have to find out and learn how to turn that around towards social inclusion by either choosing for solutions or promote that or find out the hard way, how we sometimes fail in offering support. In the end, an increased sense of equity and justice, but also empathy and compassion will lead to a successful inclusion at the end of this level. The fourth level is about urban life and the future of cities. Here we want to raise awareness of policies and visions, or apparent blindness of governments and municipalities when it comes to urban development, and now and in the far future. We want to create awareness of potentially healthy neighborhoods through citizens' initiatives that promote mutual respect, cohesion, and sustainability. Civic participation at its best. The player should also learn to value the potential resourcefulness of mixed, diverse neighborhoods, and at the same time realize that there is still discrimination, often unjust, of so-called migrant neighborhoods and the stereotyping of people who live there. This level also draws attention to the often so-called renovation of old or low-income neighborhoods that merely favors gentrification and in the end disadvantages lower incomes, evicting them to unwanted identityless suburbs. Finally, hope. A glimpse of potential cities of the future, greener, more social, self-sufficient and sustainable. Level 5 is about environment and climate change. Here we want the player to become aware of and react to a number of issues around environment, the urban, the rural, the global, that they in a way go hand in hand, like water pollution coming from cities, agriculture and industry, and its consequences for hygiene and health of humans, but also animals and plants, and all marine life. Air pollution, again from cities, agriculture, industry and transport, and its consequences for the atmosphere, like carbon dioxide and other greenhouse gas emissions, all contributing to global warming. We highlight the consequences of political governance and national and local policies, the procrastination and blame game concerning these issues, and the turning a blind eye to or facilitating greenwashing businesses. We stress the importance of generating clean, renewable energy and the importance of innovative energy storage, which can also contribute to a cleaner climate. How citizens themselves can actively do something about the seriousness of the matter and develop collaborative initiatives to help prevent further climate warming, for instance, through reusing and recycling. We are beyond the tipping point, and by now the player should be aware that action, cooperation, and collaboration, in short, civic participation, is required and can be done effectively, and that it concerns all living and future generations. And finally, level 6. Global issues and crises, civic engagement and civic participation. The players have already shown that they, whether or not in collaboration with others, can come up with solutions on a local and regional level. And now it's time to face global issues and to actively and collectively tackle any abuses. In this last level, we want the player to become aware of possible actions as a participating and responsible citizen. We are not only responsible for the present, but also for future generations. In addition, we should be conscious of the possibilities citizens have to influence governments and governance. The player will discover different democratic governance styles, which can be useful in decisions for the long term and for the good of society and humankind. We will also address the benefits and pitfalls of migration, including historical contexts. Players will also become aware of the obstacles and threats to democratic, cooperative, effective and peaceful societies, like populism, polarization, radicalization, terrorism, autocracy, dictatorship, and short-term political or business interests. The players will be introduced to successful initiatives towards new forms of democracy that can help to regain agency for citizens, which can lead to more responsible and fair long-term governance in all the fields we have highlighted in the prior levels. With a short letter to the 7th future generation, the players will finish the game and will be praised and rewarded. They have shown perseverance, resourcefulness, and responsibility. They have answered questions and they have found new questions. They are invited to share them and ask them to their family, friends, but also to their country's policymakers. If all these questions and challenges are seriously considered by all, humanity has an opportunity to survive on this planet, our small and precious home. Which concludes my presentation. Thank you.
until we are having questions for our colleague here, and I need to find your questions, please. Yes, please.
Thank you very much. It was very interesting. And how can you let other institutions, let's say, who would like to play the game, have access to this, your product?
Yeah, well,
is it possible?
We expect our pilot version, so the first version, which will be tested by everyone who is playing it. So we get all the feedback from this playing the game. We get the feedback to make it better and maybe more convincing in some.
When you have the final version, will you make it?
I think it will be available on our project website.
Project website.
Yes,
okay.
Online, and we will invite everyone on LinkedIn, on via social media and so on, to play the game, especially the 60 to 30-year-olds. And we also will invite teachers and educators to play the game, and we will try to train them how to work with the game, because it can be a nice conversation starter in class.
Yeah, thank you.
Yep.
Dinah, please.
Yes, I have a question.
Can you
because
just stand,
I saw
please?
how
Yeah.
professionally people work on scenarios. Can you share your practice, your experience, how you are doing scenarios in such a way to make it easier than for programmers to develop the game?
Yeah, well, look, I'm a lecturer at the Film Academy where I teach students to develop stories. Yeah, so I know how to make a story. And in this game, there are lots of mini stories, of course, because you have to have a problem and then you have to find the solution to the problem, which is all a game is about, a story is about. And so it's hidden all in the game, and some stories are more difficult and others are simple. But they have to cover, of course, these issues that we have to address. And so in a way, we also call it a holistic game, because it covers almost everything that's important at the moment for this world, for this planet, and for our societies anyway. And the thing was, the difficulty was, because it's so complex and it's sometimes so much, how to compress this into understandable bits of information that are still meaningful and make you think about things and make you want to find a solution to things. So sometimes we just ask questions, and now we have this and that problem. Would you solve it this way, that way, or that way? So we have a kind of multiple choice thing in it as well. But every multiple choice question has also an answer. So even a no question gives you an answer. So you learn even from your faults. You learn from your mistakes as well. Yeah. So this is the idea. And making a story, of course, that's a little bit of my profession. I used to be a copywriter as well. So I know how to write, but it's in this case it was a challenge. It was a challenge. I had to stake out my neck, you know, to my partners as well, because this is new. It will, it's difficult. And so my wall was covered with post-its and everything, and group things. And so,
but I need to say that I'm really impressed with the game, and I really, as also Isabella said, I really want to be able to bring it to the schools with whom I closely work with in our city, because I'm pretty sure it will be very, very interesting for them. I don't know how you will deal with translations and in what it is done.
It will be translated in our partner countries' languages,
Okay.
so it will be in Romanian, Polish, and so on.
So later maybe in other languages outside your partnership.
We'll see with the final version, yes.
And what is done?
Secretly, but this is my personal thing. Secretly, I hope that we will have positive feedback and we will have a nice game with this. Let's say simple animation stuff, and so secretly I'm hoping that someone will have some millions to make it the same game when it's perfected, the same game in a more, let's say, spectacular way. Yeah. That would be nice.
Thank you very much.
Thank you.
Thank you very much. I really enjoyed it.
Thank you for listening.
Thank you very much. So I will kindly invite, it's not the final paper on this session because we still have another paper which is moved from the other session. So I will kindly invite Nikita something. I know a name here, Pete Cummers. I know him. So that's I will need to ask you to say the names of the authors. I will say the name of the paper. Designing MOOC based on the framework for teacher professional development in STEAM. So please.
Okay, may I stand?
Yes, it's better to stand, I think, because they are filming with that one.
Okay, so hello everybody one more time. And I'm really happy to be here and to present our study, our results of our study. And this study is based on project, Erasmus Plus project, and co-funded by European Commission. And the study is about designing MOOC based on the framework for teachers' professional development in STEAM. And I just have to emphasize it's just a little part of the project in which we are all involved. And I am Ligita Zilskaitė-Jakštė. And here you see the other members of the project of my team. So at Kaunas University of Technology, Renata Burbaitė, Lina Narbutaitė, Armantas Ostreika, Aušra Urbaitytė, and a lot of others are engaged. Piet Commerce, as I mentioned, he is from Netherlands, and other courses, Samir, Seida, and Shukran, they are from Turkey. And the coordinator of this project is from Turkey. So here you see the website of the project. If you have interest, please come and visit. And this project will be finished at the middle of next year. So the aim of the project to employ an innovative and up-to-date framework and solutions with the participation of 10 EU partners. As I mentioned, Turkey is involved in this project as well, and they are coordinators for employing an effective STEAM approach in education and developing the related teacher skills and curriculum. So here you see all the project partners. And as I mentioned, we'll present just small part of this project, and Kaunas University Technology was responsible for work package 2, teachers training and training curriculum preparation. And our challenge was to think how to design MOOC in order to engage teachers for professional development and at the same time, we had to think how to engage robotics in this. As you know, robotics can encourage our creativity, but it is still related with tangible kids. And when we are talking about trainings online, it may be a challenge how to prepare a good course for teachers. And so the aim of the study which we prepared for this conference, the aim is to present relationship between framework for teachers' professional development in STEAM and MOOC platform. And main objectives, at first we made analysis of different STEAM models and different theories, and tried to conceptualize all of this conception and object, and to think what fits for us or what doesn't fit. And later I'll present the framework which we prepared, and then how we tried to design MOOC according to this conceptual framework. So we all agree that STEAM is quite important, and what will give our kids, our school children now, and how good teachers will be prepared now, it depends what future we'll have. So yes, all agree that STEAM is quite important, but at the same when we want to integrate robotics, as I mentioned, it's quite a big challenges. How to do this? So we used different, analyzed different STEAM professional development models for teachers development. Then we analyzed different theories, and in general we applied a holistic approach and tried to involve a lot of aspects from different models. And for example, meaningful learning model we used because we decided to use learner-centric approach. This means that learners is the most important in the education process, and for example, teacher works as a mentor. So this means that teacher can help just provide some guidelines. And here you see the our conceptual model, and we used layers learning approach proposed by Boyle, and here you see two layers. So one of them is related with STEAM-driven learning content, and other second layer is related with pedagogical aspects. So it was challenge how to integrate all these elements into the MOOC. And yeah, so target group was, and we organized trainings, piloting training for the MOOC and all this in order to identify the main aspects what fits in this case. And in general, more than 400 teachers registered to the platform, and just 119 got certificates. And here you see that 227 provided their reflections, so they filled the questionnaire. And for the evaluation, we used Likert scale from 1 to 7 point. And here you see some elements of the platform. So it was 3 units prepared, and the first and the second unit was related with theoretical information, and unit 3 and unit 4 was related with practical tasks. So it was, in invitation it was written that we are inviting you to participate in this piloting teachers who have previous knowledge about robotics. But later the answers to the questionnaire show that there are a lot of participants, this means learners, who didn't have previous robotical language. Therefore, it was quite difficult for them to do all the tasks and even to understand, because these tasks and all the information was in English. And we identified that, yeah, it's very important issue is language, and as well previous knowledge. So, and here you see several tables where we tried to transfer these elements from conceptual model to MOOC. And yeah, and after that, when we got the reflection, the evaluation from teachers, we identified that they want to do everything very intuitive. They don't have need, they don't want to learn how to use the platform. They just want to understand everything from the first sight, and even sometimes maybe they should need to use more efforts in order to understand and to learn a little bit about some particular platform. So, but in general, the results are quite good, and as we see that teachers evaluated this content quite good, and yeah, 143 3, it's 62% of participants told that they got knowledge of STEAM teaching scenarios, and 61% told that knowledge of STEAM teaching they got, and 56% knowledge of STEAM in general. So, and here you see the similar slide, aspects in which the course helped to obtain teaching practices. So the biggest part of the participants told that creating STEAM learning scenarios. So we provided even some templates for scenarios creation, for robotics, for chatbots creation, and as well they had to do some tasks related with this. And here you see I have gained practical ideas on how I can improve my professional practices in STEAM learning scenarios and robotics. And 64 of respondents choose the 7 point. As we mentioned, it's Likert scale, and the 4 is the middle point. So this means that they don't agree nor disagree. And findings, in short, yes. So these trainings these trainings lasted for 4 weeks, and it was volunteer teachers who provided some live sessions for trainees. But as we identified from the answers, open-ended questions, that it was not enough just to get some information, one-way information, because it's always important, especially for those who don't have previous experience, to have two-way communication and even consultations and even some examples to show how to work with all these kids, robotical kids. And well, this piloting was implemented just in Turkey and Spain, and now we made some improvement, and now when we'll finish all the improvement, so I hope that in another EU countries we'll implement piloting trainings as well, but still it will be in English. And here, so we propose the framework, we apply this framework and designed MOOC, and now we made some improvements. And after this second trainings, we'll get reflections of participants, and we'll see how it works. But at the same time, I want to mention that at first we, in Unit 4, we had just 2 levels. So for those who work with Arduino, so it was like beginners level, and another level for those who have some experience. And now we understood that, but these tasks were related with tangible kids. So this means they should have by themselves these Arduino kits and to do something. But now we prepared some lessons, video lessons related with Tinkercad, and it will be like beginners for those who don't have any ideas about robotical education, and we hope these videos online will make some like introduction, and if teacher will be really engaged in such training, so later it will be easier for them to go to another levels. So thank you. And
thank you very much for this. Questions, please. Yes, Peter.
I have 2 questions.
Oh, okay.
Brief.
How would you define the A in STEAM, arts? So how do you define it?
Yeah, I will answer this question after we'll finish all our project, because still with our partners, we are discussing how to define, and like one of the work package is to prepare like guidelines for STEAM education in European level, and as well to engage our learning. So at the end of this project, I can give you brief definition of this.
Okay, and the other thing is, I saw how much could the teacher implement STEAM and robotics in his subject, his, her, their subject. Isn't it sometimes that STEAM or STEM is meant to be cross-disciplinary or interdisciplinary? So it's not only your subject, but every subject.
Yeah. Yes, I agree with you, but as well we are talking about different teaching methods where it is possible to engage teachers from different disciplines and even to encourage creativity in all subjects.
Because it would be interesting for learning scenarios, for instance, or project-based learning, for instance. It would be interesting to look at what different subjects can mean for each other.
Yeah, but it's related with creativity, with time, with motivation, teachers to be engaged in this.
I'm also saying it because in the Netherlands, it's totally in infancy. They don't know so much about STEAM in the Netherlands.
Okay, so you can carry on over dinner if we manage to get to dinner. So this is your certificate. Thank you very much. So we have now a paper which is still left from the previous session. I deeply apologize for this. So we have topic modeling for tracking COVID-19 communication on Twitter from Petar Christian Bogovic and Anna Mestrovic and Sanda Martinic-Ipsic. So can we have Petar live? Good.
Yes, hello. Can you hear me?
Yes, we hear you quite well, so please.
Okay, let me just set up the...
So if you move to slide share, we can also see your presentation.
Can you see it?
Perfect, yes. Thank you so much for this. Please start. I will give you maximum 12 minutes, so please be aware of that.
I will try to be quick. Okay.
So, good afternoon. My name is Petar Christian Bogovic, and today I will present my paper entitled Topic Modeling for Tracking COVID-19 Communication on Twitter, which I co-authored with Ana Mestrovic and Sanda Martinic-Ipsic from the University of Rijeka in Croatia. So, recently we have seen a large increase in textual information in general, and with COVID-19 pandemics, textual information led to an overabundance of information, also called infodemics. Our goal of our research was to try to establish or improve information monitoring in Croatian online media and to gain a better understanding of crisis communication. How did we try to achieve this? By applying topic modeling to online media related to COVID-19, primarily tweets mentioning the coronavirus, and by analyzing topic trends and information dissemination in the form of retweets. It is also worth mentioning that the research was conducted within the InfoCov project funded by the Croatian Science Foundation. So the methods that we used consist of latent Dirichlet allocation, the standard method for topic modeling, which represents documents as random mixtures of latent topics, where topics are characterized by a distribution of words in a document. The number of topics selected for modeling was determined using normalized pointwise mutual information. And this method scores the topics in terms of human perception of semantic understandability. And the model with the highest coherence value indicates the best selection for the number of topics. So the source for our textual data is Twitter. Data was collected during the first 3 waves of the pandemic between the January 1st of 2020 and May 31st of 2021. We only collected tweets that mentioned keywords such as corona, COVID-19, coronavirus, and SARS-CoV-2. Before applying topic modeling, the data was pre-processed and we removed duplicate comments, stop words, emojis, non-creation tweets. To reduce morphological forms in text and improve accuracy, we use the class lemmatization. And after cleaning, we were left with 100,047,028 tweets. So next, we have the results of applying previously mentioned methods to our data. We calculated the coherence score for models with a number of topics ranging from 4 to 12, with the highest coherence score obtained for a number of 7 topics. First, we have the topic of epidemic prevention with keywords such as to wear, want, person, mask. Second, the topic of life during the pandemic with keywords such as corona, no, infect, not have. Third, the topic of political with keywords such as headquarters, prime minister, media, pandemic. Then the topic of vaccination with keywords such as vaccine, vaccination dose, receive. Fifth, the topic of official anti-pandemic measures with keywords such as headquarters, civilian, protection, epidemiological, and measures. Sixth, the topic of the number of new COVID-19 cases with keywords such as coronavirus, again, new case, test. And finally, the topic of epidemic prevention with keywords such as county, self-isolation, and positive. Next, we analyze the distribution of tweets among topics and the dynamics of change during the observed period. So most topics account for 10 to 20% of the total dataset. The topic of anti-pandemic measures, which focuses on emergency response measures, accounts for slightly less than 10%. While the topic of coronavirus infection, which focuses on general information about specific infected individuals, accounts for less than 7% of the total datasets. During the 3 epidemic waves, the distribution of tweets among topics deteriorates between 2.2 to 3.7%, while the topic of vaccination shows a gradual constant increase from 14.6 in the first epidemic wave to 25.7 in the third epidemic wave. The next figure shows the evolution of the frequency of tweets distributed over 7 topics over time on a monthly basis. The spikes on the graph shown coincide with the spikes in the COVID-19 bursts. For most topics, we have an even distribution, again, apart from vaccination, which increases in the fall of the year 2020 and subsequent months as the vaccination becomes more important. Next, we examine the spread characteristics of topics in terms of retweets. We can highlight the topic vaccination with the highest percentage of retweets and the topic of life during the pandemic with the lowest percentage of retweets, as seen in panels A, which is a comparison between number of retweets and the number of tweets, and B, which is the retweet ratios of the topics. In panels C and D, which show the total retweets per month per topic and the retweet ratio per month per topic respectively. We analyze the number of retweets and the ratios and conclude that the highest number of retweets is at the beginning of pandemic. All topics show a similar retweet distribution, although the topic of vaccination again shows different characteristics. Tweets on the topic of vaccination were retweeted very frequently in the fall of 2020, and this trend continues in the next years. Finally, so to conclude, we applied topic modeling to COVID-19 related tweets in Croatian during the first 3 epidemic waves. We used LDA and topic coherence for automatic topic derivation. All topics are evenly distributed over the observed period in terms of the distribution of tweets, number of retweets, and ratio of retweets, except again for the topic of vaccination, which stands out. In contrast to the other topics, the distribution of vaccination increased from 14.6 to 25.7% in the last wave and has the highest number of retweets peaking in the fall of 2020. Our findings, or these results, are a first step towards a better understanding of crisis communication and information monitoring in social networks. The identified topics can serve as a basis for long-term monitoring of trends, including information dissemination in the form of retweets. Translating this process to other languages depends on the natural languages processing support those languages provide. In the future, we plan to extend our work to other social networks and apply a broader range of natural language processing methods, such as keyword extraction, sentiment analysis, and name entity recognition, so you can have a better insight into what's happening. And that would be it. If you have any questions, feel free to ask them now, or you can send an email to me or my colleagues at the email addresses shown on the screen.
This? Can I ask you to switch off the screen share so we can see you much better?
Yes.
Okay, good. And I don't know if you can see us, but we're quite a lot. I don't dare turn the screen here or the camera. Can I?
I'm seeing you. I'm seeing you, but not the rest of the.
Oh.
Okay, yes, I can see all of you now.
Okay, so you see everybody now.
Yes, hello.
Good. I have a question for you, and the question is: do you see that the trends on tweets, the spikes which you've said, and you related them with a social change? But do you see this, that if the social change is only the beginning, the trend keeps going on because of retweeting and technical reasons, or it's still only a social one?
Sorry, I did not hear you very well. Could you please repeat?
Yes, I will. I need to turn also the camera. Okay, I'll turn the camera. I'm sorry. Good. I'm so sorry. So, yeah. So my question is that it's based on research, previous research more or less, that if the first spike of a trend in Twitter is due usually to a social change, or social, economical, doesn't matter, change. But to keep the trend going is usually also a technical change or a technical reason. Do you have seen the same thing or not?
How do you mean a technical reason?
Okay, I know it's a tricky question. Technical reason, which means retweets by bots, retweets by other systems or something like that to increase the visibility of certain hashtags or something like that.
Well, it might be both. We've tried to eliminate the accounts that were, of course, just making duplicate posts. So anything that had the same time of posting and identical content was removed. So any duplicates in this data that we shown, well, it was removed. So anything that should have been, like you said, exaggerated by bots was supposed to be more or less eliminated from the data. So what we have here should be, clean, but it all depends on how do you know something is a bot or not. So I'm not sure if I've answered your question in any way.
I know it was a tricky question, so it's never an easy question with me. So this is your certificate, which somehow you will manage to get it. I don't know how, but you will get it somehow, okay?
Okay.
Thank you very much for this. All the best.
Thank you. Goodbye.
Bye. So I finished. Now somebody else needs to take the floor to give the best paper awards.
Okay.
And this is my certificate. Just to know that this is the one which I take.
Yes. No, this is your certificate. That's the GR.
This is very lovely. Thank you so much.
So, okay. Let's move to the most important part of our conference. Sorry. So it's kind of just a moment. So please relax, it will take for 1 or 2 minutes, all this procedure. So please be patient.
You know, this is just raising the suspense. You know?
Just a moment. So, okay, it should work. Okay, so now we're starting the most important part. So is no, it is not necessary. Sharing for Zoom. It is not necessary to share Zoom. Yeah, you can see the remote participants can see this slides as well. So it was, as I mentioned, the most important part because it was very hard to choose the best of the best presentation. Yeah, and we were working according to kind of criteria like, for example, completeness of introduction. Of course, the primary was criteria the idea. Yeah, to that the criteria were the like completeness of introduction, methodological issues, the proposal, the practical implementation, and of course the possibilities to put the particular solution into the practice, yeah, and maybe to go to kind of commercial issues, yeah. So our decision is that best paper award goes to Commander Kumar. Yeah, so title IoT application powered by piezoelectric vibration energy harvesting device. So please come here and congratulations. So please applause. Okay, and of course I would like to promote and invite all of you to our next year ICIST 2023 conference. the main information regarding all the deadlines, dates, and other things you will find in our web page. Of course, you will find it in the last page of this year program, yeah. So we kindly invite you here, yeah. The format of the conference, we hope that it will be blended, yeah. And thank you very much. And of course, I would like to say a very big thank you for all who contributed to organize this conference. So especially for program committee members, yeah, for organizing committee members, for all of you, for all the participants, especially for technical staff who did a huge job, especially Walker's team, yeah, and all others who contributed but did not mention it. Very, very thank you, because this event is the result of the joint activities, yeah, and all the parts are necessary in order to organize the event like this. So thank you very much, and see you next year, latest next year. Okay, thank you.